Hello. Okay, now I think everything is fine now. Everyone, very good morning. This is Sanjay Rathi, and this is session on what complete BJT. It is a part of GATE Marathon Analog Electronics complete BJT with previous year questions. We are going to solve some important numericals from BJT. Okay, एक ना ये complete revision है. अगर आप इस सब्जेक्ट में कमांड करना चाहते हैं या आप अपनी प्रिपरेशन चेक करना चाहते हैं कि इज इट इन अ राइट डायरेक्शन, देन दिस इज सेशन फॉर यू. बहुत सारी बातें हम लोग डिस्कस करेंगे, जैसे कि बाइसिंग एंड स्टेबलाइजेशन ऑफ बीजेटी, राइट, लो एंड हाई फ्रीक्वेंसी एनालिसिस ऑफ बीजेटी, एम्पलीफायर बाय यूजिंग बीजेटी, करंट मिरर सर्किट, वोल्टेज रेगुलेटर बाय यूजिंग बीजेटी. ओके, स्टे ट्यून्ड विद मी. आई थिंक एवरीथिंग इज फाइन नाउ. Low and high frequency analysis of BJT, amplifier by using is it any disturbance by using BJT. Okay, stay tuned with me. I think everything is fine now. 1 minute. Okay, now I'm going to start my session to GATE Marathon Analog Electronics complete BJT with previous year question. This is important for coming exam like GATE and engineering services and other competitive exams. Raj, very good morning. Now, this is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. The voice is getting noise. Now it is fine. Okay. 1 minute. Give me 1 minute. Now please check. Is everything is fine now? Okay. So guys, very good morning. This is GATE Marathon Analog Electronics complete BJT with previous year questions. Okay. Then that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam. I worked as deputy director in Ministry of Power, and I have trained more than 1 lakh students for various competitive exams. Okay. Then guys, this is my channel Electronics by Sanjay Rathi. I will upload the PDF of this session on this particular channel. So please join that. अब आप इंस्टॉल कर सकते हैं माई ऐप, दैट इज प्रेप फंडर. दैट लिंक इज गिवन इन डिस्क्रिप्शन. अभी अब एक कोर्स आप लोग ले सकते हैं इफ यू वांट टू गेट द कमांड ओवर ऑपरेशनल एम्पलीफायर विद इन 30 days, राइट. तो आप टॉपिक वाइज भी ये कोर्स ज्वाइन कर सकते हैं. दैट इज ओनली ऑन एट द रेट ऑफ व्हाट 251. वैलिडिटी है ओनली 30 days. ये रिकॉर्डेड क्लासेस हैं. साथ में जो आप लोग क्वेश्चंस बना रहे हैं, अभी हम लोग क्वेश्चन सॉल्व कर रहे हैं, वो तो आप सॉल्व करेंगे ही, राइट. And then similarly we can you can Okay, guys. I think now everything is fine. Some technical issue, guys. Now, this is Sanjay Rathi. Guys, we are going to discuss analog electronics complete BJT with previous year questions. Now, everything is fine. Okay, guys. First of all, that is my introduction. Myself Sanjay Rathi, right? And I have qualified and selected for engineering services exam. Now, BJT, MOSFET, and operational amplifier. These three topics are important for all competitive exams, especially for GATE. जो भी आपका GATE का एग्जाम होने वाला है, इन टॉपिक्स का हमको रिवीजन करना है. तो आज हम लोग करेंगे व्हाट बीजेटी, कंप्लीट बीजेटी. जो आपकी डिमांड है एडीसी, इलेक्ट्रॉनिक डिवाइसेस एंड सर्किट, उसे मैं कवर करूंगा जस्ट आफ्टर दिस गेट एग्जामिनेशन, क्योंकि इलेक्ट्रिकल वालों का गेट पहले है. तो इलेक्ट्रिकल के गेट में आपको देखोगे कि एनालॉग है, ईडीसी नहीं है, इलेक्ट्रॉनिक डिवाइसेस एंड सर्किट. तो अभी आप इन सब्जेक्ट्स में कमांड कर दो, then we will cover the electronic devices and circuit, guys. And that is my Telegram channel. I will upload the PDF on this. And ये मैंने आप लोगों के लिए, अभी कुछ लोगों ने डिमांड की कि सर मुझे ऑपरेशनल एम्पलीफायर में कमांड करनी है या फिर बीजेटी में या फिर मॉसफेट में, तो यू कैन ज्वाइन ऑन माय ऐप. ओनली 251, द वैलिडिटी इज फॉर 30 days. रिकॉर्डेड सेशंस अवेलेबल है. आप जीरो से लेकर टॉप मोस्ट जहां तक भी आपको समझना है, पूरा कंप्लीट बीजेटी, कंप्लीट ऑपरेशनल एम्पलीफायर, कंप्लीट मॉसफेट फॉर एनालॉग आप रिवाइज कर सकते हैं. अभी आज ज्वाइन कर लीजिए तो विद इन 30 days आप लोग इसमें कमांड कर लेंगे. आज ये अगर इलेक्ट्रिकल वाले हैं तो 10 दिन लगेगा, ठीक है ना. 2 से 4 दिन में भी आप इस पे सब्जेक्ट को रिवाइज कर सकते हो, A to Z बेसिक से लेके टॉप लेवल तक. तो ये आप लोगों के लिए. और जिनको ज्वाइन करना है फॉर ये 2026 एंड 2027, they can join for full course. For more detail call me at that number is given on screen. ठीक है, वहां पर कॉल करो, पूरी डिटेल लो, उसके बाद आप ज्वाइन कीजिए. जब एक बार आपको समझ में आ जाए कि कैसे सेशंस होते हैं, कैसी क्लासेस होती है, डेमो क्लासेस लीजिए. जब आपकी और मेरी फ्रीक्वेंसी मैच हो जाए तब आप ज्वाइन कीजिएगा. ऐसे आप बिना किसी उसके हड़बड़ी में ज्वाइन मत कीजिए, अदरवाइज आप कोर्स को एंजॉय नहीं कर पाएंगे, राइट. तो यहाँ पर लाइव सेशंस, रिकॉर्डिंग, प्रीवियस ईयर क्वेश्चंस फ्रॉम बुक्स, डाउट क्लियरिंग सेशंस होंगे. थोड़ा सा आप टाइम दीजिए. जैसे फॉर इंजीनियरिंग सर्विसेज एग्जाम प्री के लिए थोड़ा टाइम है अप टू जून, तो वहां हम लोग 6-7 सब्जेक्ट अच्छे से कर सकते हैं. फॉर गेट एग्जामिनेशन 2026 वहां तक हम लोग फुल कोर्स बहुत ही डिटेल में विद डिटेल नोट्स, शॉर्ट नोट्स, प्रीवियस ईयर क्वेश्चंस, डाउट क्लियरिंग सेशंस कंप्लीट कर सकते हैं, राइट. अब आते हैं जरा बीजेटी में. देखो बीजेटी में अगर आपको कमांड करनी है बीजेटी, बाइपोलर जंक्शन ट्रांजिस्टर, तो सबसे पहले आपको ना थोड़ा सा बेसिक पता होना चाहिए अबाउट व्हाट रीजंस, कट ऑफ रीजन, एक्टिव रीजन एंड व्हाट सैचुरेशन रीजन. तो व्हाट आर द डिफरेंट रीजंस, राइट. कट ऑफ, एक्टिव, सैचुरेशन. नॉर्मली जो क्वेश्चंस आते हैं दैट इज ऑन व्हाट एक्टिव रीजन. ओके, लेकिन ऐसा नहीं है, सैचुरेशन पर भी आ सकता है, कट ऑफ पर भी आ सकता है. सब कुछ हम लोग डिस्कस करेंगे यहाँ पर. उसके बाद जब हम लोग जाते हैं तो उसके बाद आ जाएगा बाइसिंग. बाइसिंग का मतलब ही होता है कि आपको किस रीजन में रखना है ट्रांजिस्टर को. फॉर एग्जांपल एक्टिव रीजन में. तो जब आप इसे एक्टिव रीजन में रखना चाहते हैं तो क्या करोगे आप, विद द हेल्प ऑफ डीसी, विद द हेल्प ऑफ डीसी सप्लाई, जिसको हम लोग लार्ज सिग्नल बोलते हैं, उसे हम लोग रखते हैं इन एक्टिव रीजन, ऑल इन व्हाट कट ऑफ रीजन, ऑल इन व्हाट सैचुरेशन रीजन. देन आता है आपका बाइसिंग के बाद आ जाएगा स्टेबलाइजेशन. स्टेबलाइजेशन अब बताइए जरा, स्टेबलाइजेशन में आपको कौन कौन से मेथड याद आते हैं? ओके, ऑल गुड. चलिए स्टेबलाइजेशन में जैसे आपका बात करेंगे फर्स्ट फिक्स्ड बायस सर्किट, देन सेल्फ बायस सर्किट, देन कलेक्टर बेस्ड बायस सर्किट, फिर आता है करंट मिरर सर्किट. ओके, यहाँ क्यू पॉइंट स्टेबलाइजेशन, स्टेबिलिटी फैक्टर क्या है, ये सब क्वेश्चंस आएंगे. देन इस पर ही आपके पूरे क्वेश्चंस बन जाते हैं, कट ऑफ रीजन, एक्टिव रीजन, सैचुरेशन रीजन एंड सो ऑन. देन गाइस इसको एक बार कमांड करने के बाद अब आ जाएंगे एम्पलीफायर. एम्पलीफायर बाय यूजिंग बीजेटी. तो एम्पलीफायर बाय यूजिंग बीजेटी में हमारे पास आ जाते हैं मॉडल्स. मॉडल्स मींस आरई मॉडल. आरई मॉडल नॉर्मली आजकल क्वेश्चन आरई मॉडल से बन जाते हैं, दैट इज आल्सो कॉल्ड टी मॉडल या फिर हाइब्रिड पाई मॉडल। हाइब्रिड पाई मॉडल, देखो गेट में ना जितने भी क्वेश्चन होते हैं ये दोनों से बन जाते हैं। पहले एक और मॉडल आता है जो नेटवर्क में हम लोग पढ़ते थे, एच पैरामीटर। एच पैरामीटर मॉडल, हाइब्रिड मॉडल, जिसमें हम लोग 4 पैरामीटर पढ़ते हैं, एच आई, एच आर ई, एच एफ ई, एच ओ ई। अब देखो ज्यादातर क्वेश्चंस, ये मॉडल उतना एक्यूरेट नहीं है, एफिशिएंट नहीं है, इसीलिए ज्यादातर क्वेश्चन जो अब बनेंगे वो बनेगा या तो आरई मॉडल से या फिर हाइब्रिड पाई मॉडल से, राइट। इनको बोला जाता है स्मॉल सिग्नल मॉडल। तो यहां हम लोग सॉल्व करेंगे नंबर ऑफ क्वेश्चंस ऑन दिस। ओके, उसके बाद है, जब ये आपको टॉपिक समझ में आ गया, यहां आपको समझना पड़ेगा कॉमन एमिटर क्या होता है, कॉमन कलेक्टर क्या है, कॉमन बेस कॉन्फ़िगरेशन का मतलब क्या है। तो इस मॉडल को हम लोग कॉमन एमिटर के लिए यूज करेंगे, कॉमन कलेक्टर के लिए यूज करेंगे, कॉमन बेस के लिए यूज करेंगे। एंड देन फाइनली जब तीनों आपने एक बार बना लिया, फिर हम एंटर करते हैं हाई फ्रीक्वेंसी एनालिसिस में। हाई फ्रीक्वेंसी एनालिसिस, हाई फ्रीक्वेंसी एनालिसिस ऑफ बीजेटी। अब पॉइंट ध्यान दीजिएगा, जब हम बात करते हैं हाई फ्रीक्वेंसी एनालिसिस ऑफ बीजेटी, तो ये जो टॉपिक है इससे काफी कम क्वेश्चन आते हैं फॉर इलेक्ट्रिकल इंजीनियरिंग, लेकिन इलेक्ट्रॉनिक इंजीनियरिंग में कभी कभार इसमें से क्वेश्चन आते हैं हाई फ्रीक्वेंसी एनालिसिस। तो नॉर्मली 3 एनालिसिस है, लो फ्रीक्वेंसी एनालिसिस, मिड फ्रीक्वेंसी एनालिसिस एंड हाई फ्रीक्वेंसी एनालिसिस। तो वी आर रीडिंग क्वेश्चंस फ्रॉम व्हाट, मिड फ्रीक्वेंसी एनालिसिस। Mid frequency analysis, find the voltage gain, find the input resistance, find the trans conductance and so on. कई बार आपको बोलेगा थेवेनिन इक्विवेलेंट निकालिए, नॉर्टन इक्विवेलेंट कैलकुलेट कीजिए, इस तरीके से आपके क्वेश्चन बनेंगे दोस्तों। ओके, नाउ अब स्टार्ट करते हैं हमारा सेशन। देन देखो दोस्तों, बीजेटी बाइपोलर जंक्शन ट्रांजिस्टर की जहां तक बात है, ये देखो ये है सिंबल फॉर एनपीएन ट्रांजिस्टर। देखो ये एरो बाहर जा रहा है, ये एमिटर टर्मिनल, कलेक्टर टर्मिनल, बेस टर्मिनल, ये उसका फिजिकल स्ट्रक्चर है। देखो एमिटर का एरिया कलेक्टर से कम है, लेकिन इसकी डोपिंग सबसे ज्यादा है। सबसे थिनेस्ट पार्ट आपको दिखाई दे रहा है बेस, उसके बाद सबसे ज्यादा एरिया है कलेक्टर का। इसका मतलब ये एक असिमेट्रिकल डिवाइस है। क्या है ये? असिमेट्रिकल डिवाइस है। एमिटर की डोपिंग सबसे ज्यादा है, बेस का एरिया सबसे कम है, थिन है, और कलेक्टर का एरिया सबसे ज्यादा है। दिस एक्ट एज व्हाट, सिंक, दिस एक्ट एज व्हाट, सोर्स। एनपीएन ट्रांजिस्टर में एमिटर का काम है इलेक्ट्रॉन प्रोवाइड करना। नॉर्मली वी आर यूजिंग व्हाट, एनपीएन ट्रांजिस्टर, क्योंकि इलेक्ट्रॉन की जो मोबिलिटी होती है वो होल के कंपैरिजन में ज्यादा होती है। दैट्स व्हाई वी आर यूजिंग व्हाट, एनपीएन ट्रांजिस्टर गाइस, एनपीएन ट्रांजिस्टर। ओके, देन ये देखो, ये आप अगर आप मार्केट में परचेस करने जाओगे ट्रांजिस्टर, तो आपको ऐसा दिखाई देगा। कई बार क्या होता है, इंटरव्यू में आपसे पूछा जा सकता है कि आपने ट्रांजिस्टर देखा है, तो अभी चले जाइए शॉप में, वहां पर आप जाकर ट्रांजिस्टर, मॉसफेट, ऑपरेशनल एम्पलीफायर, 555 टाइमर की चिप आप देख सकते हो, राइट। देन ये एक ऐसा सिंबल है जैसे आपको लगेगा जैसे दो डायोड बैक टू बैक कनेक्टेड है। यहाँ पर एक डायोड लगा हुआ है, देखो ये है पी टाइप, एन टाइप, then p type, n type, और यहाँ बेस टर्मिनल, दिस इज द कलेक्टर टर्मिनल एंड दैट इज व्हाट, एमिटर टर्मिनल। लेकिन अकॉर्डिंग टू एबर्स मोल मॉडल, अकॉर्डिंग टू एबर्स मोल मॉडल, वी कांट डिजाइन व्हाट, ट्रांजिस्टर बाय कनेक्टिंग टू डायोड बैक टू बैक। ऐसा अगर आप दो डायोड को लेकर बैक टू बैक कनेक्ट करेंगे तो ये ट्रांजिस्टर जैसा बिहेव नहीं करेगा, याद रखिए। भले ही हम डायग्राम ऐसा शो कर रहे हैं कि एक दो जंक्शन है यहाँ पर, ये है पीएन जंक्शन एक, जिसको बोलते हैं कलेक्टर जंक्शन, ये एक और जंक्शन है, दिस इज कॉल्ड एमिटर जंक्शन, कलेक्टर जंक्शन एंड एमिटर जंक्शन, बेस इज कॉमन। लेकिन हम दो डायोड को बैक टू बैक कनेक्ट करके क्या नहीं बना सकते, बीजेटी नहीं बना सकते, राइट। बीजेटी, वी कांट डिजाइन बीजेटी बाय कनेक्टिंग टू डायोड्स बैक टू बैक। ओके, नाउ तो चलिए ये तो हो गया बेसिक इसके बारे में अबाउट द बीजेटी। हाईएस्ट डोपिंग याद रखिएगा एमिटर की होती है और सबसे ज्यादा एरिया होता है कलेक्टर का। अब आते हैं डिफरेंट रीजंस क्या है, जहां कैसे हम लोग बनाते हैं, क्या 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 होना चाहिए। वन मिनट, देखो जब हम बात करते हैं तो देयर आर डिफरेंट रीजन लाइक कट ऑफ, एक्टिव एंड सैचुरेशन। और एक और होता है जिसको हम लोग रेयरली यूज करते हैं, दैट इज कॉल्ड रिवर्स एक्टिव मोड। रिवर्स एक्टिव, राइट। रिवर्स एक्टिव के अपोजिट इसको कई बार बोल दिया जाता है फॉरवर्ड एक्टिव मोड और व्हाट, राइट। दैट इज द रिवर्स एक्टिव मोड, फॉरवर्ड एक्टिव मोड और नॉर्मल एक्टिव मोड, राइट। ये है रिवर्स एक्टिव मोड ना। और इनवर्स एक्टिव मोड, यहां पर क्या है, तो आपके पास दो जंक्शन है, एमिटर जंक्शन एंड कलेक्टर जंक्शन, एमिटर जंक्शन एंड कलेक्टर जंक्शन। कट ऑफ में हमको दोनों को क्या करना है, रिवर्स बायस करना है। एक्टिव में क्या करना है, इसे फॉरवर्ड बायस करना है, दिस जंक्शन शुड बी व्हाट, रिवर्स बायस। सैचुरेशन में बोथ द जंक्शन शुड बी फॉरवर्ड बायस। और ये जो रिवर्स एक्टिव मोड है, यहां एमिटर जंक्शन रिवर्स बायस होगा और कलेक्टर जंक्शन फॉरवर्ड बायस। फॉरवर्ड बायस जैसे कि आप डायोड को करते हैं फॉरवर्ड बायस, वैसा। नाउ सबसे ज्यादा जो मोड यूज होता है वो है एक्टिव मोड, क्योंकि हमें एम्प्लीफिकेशन चाहिए। तो जब भी आपको एम्पलीफायर बनाना है तो नॉर्मली इट इज इन एक्टिव मोड फॉर एम्प्लीफिकेशन। मल्टी स्टेजिंग में भी हम लोग यूज करते हैं, तो ये है एम्पलीफायर की। स्विचिंग एक्शन, स्विचिंग एक्शन का मतलब होता है स्विच या तो ऑन है या फिर ऑफ है। देन वी आर यूजिंग व्हाट, कट ऑफ एंड सैचुरेशन। कट ऑफ का मतलब ऑफ हो गया और सैचुरेशन का मतलब ऑन हो गया। तो ये दो जो है ये यूज होते हैं फॉर व्हाट, स्विचिंग एक्शन, स्विचिंग एक्शन। अब आप बोलोगे सर रिवर्स एक्टिव मोड का कहीं यूज है? बिल्कुल यूज है। रिवर्स एक्टिव मोड रेयरली यूज होता है जहां पे आपको बहुत ही लो एम्प्लीफिकेशन चाहिए, देन वी आर यूजिंग व्हाट, रिवर्स एक्टिव मोड। आप टीटीएल ट्रांजिस्टर ट्रांजिस्टर लॉजिक में जाइए, वहां आपको एक ट्रांजिस्टर दिखाई देगा, दैट इज इन व्हाट, रिवर्स एक्टिव मोड, जो कि दैट इज द पार्ट ऑफ व्हाट, लॉजिक फैमिली। तो वहां से आप लोग देख सकते हैं रिवर्स एक्टिव मोड का क्या एप्लीकेशन है। ओके, देन तो ये तो हो गया कट ऑफ, एक्टिव, सैचुरेशन एंड व्हाट, रिवर्स एक्टिव मोड। देन अब आते हैं जरा, ठीक है, आप डिफरेंट क्वेश्चंस, जैसे क्वेश्चंस में आप देखकर बताइए कि कौन कौन से मोड में, जैसे बहुत ही बेसिक जाते हैं कि कैसे हम लोग विद द हेल्प ऑफ डीसी कैसे एडजस्ट कर सकते हैं। फाइंड द रीजन ऑफ ऑपरेशन, सैचुरेशन मोड में है या कट ऑफ मोड में है, एक्टिव रीजन मोड में है, इनवर्स एक्टिव रीजन मोड में। ये है बीजेटी, राइट। यहाँ पर आप देखिएगा एक बीजेटी आपको दिखाई दे रहा है। 3 वोल्ट की बैटरी यहाँ लगी हुई है, 1 वोल्ट की बैटरी यहाँ लगी हुई है, 5 वोल्ट की बैटरी यहाँ लगी हुई है। तो कमेंट्स बॉक्स में बताइए जरा ये कौन से मोड में है गाइस, इन विच मोड। याद रखिए ये एनपीएन ट्रांजिस्टर है, एनपीएन ट्रांजिस्टर। ये एरो देखकर आप बता सकते हैं दिस इज द एनपीएन ट्रांजिस्टर, जिसका बेस जो है वो 3 वोल्ट पर है, एमीटर 1 वोल्ट पर। तो बेस इज हायर देन व्हाट, एमीटर, दैट्स व्हाई वी कैन से एमीटर जंक्शन इज फॉरवर्ड बायस। एमीटर जंक्शन इज फॉरवर्ड बायस, ये वाला जो जंक्शन है फॉरवर्ड बायस। देन कलेक्टर इज एट 5 वोल्ट, कलेक्टर इज एट हाई पोटेंशियल एंड द बेस मींस व्हाट अबाउट दिस जंक्शन, रिवर्स बायस। देखिए विद द हेल्प ऑफ डीसी हमने यहाँ पर क्या किया, कलेक्टर जंक्शन को रिवर्स बायस कर दिया और बेस एमिटर जंक्शन को क्या कर दिया, फॉरवर्ड बायस कर दिया। मींस द ट्रांजिस्टर इज इन एक्टिव रीजन, एक्टिव रीजन, सैचुरेशन, कट ऑफ, एक्टिव और इनवर्स एक्टिव रीजन। ओके, तो दिस इज व्हाट लार्ज सिग्नल गाइस, इसीलिए हम लोग डीसी को बोलते हैं लार्ज सिग्नल। ये कंपैरेटिव टर्म है, हम लोग यहाँ पर लार्ज सिग्नल लगाकर इस ट्रांजिस्टर को अभी हमने किस पे रखा हुआ है, एक्टिव मोड में। सिमिलरली इस क्वेश्चन में देखिए जरा, एमीटर को कनेक्ट कर दिया गया ग्राउंड से, बेस में लगाया गया 3 वोल्ट नेगेटिव वोल्टेज, नेगेटिव वोल्टेज। बताइए जरा, ये आपका -3, इसको कर दिया गया ग्राउंड। देखो अगर ये positive terminal voltage is less than what, negative terminal voltage, means definitely this junction is what, reverse bias, यहां लगा दिया गया है 5 वोल्ट। अगेन नेगेटिव टर्मिनल वोल्टेज और जो एन टर्मिनल पे जो वोल्टेज है वो पी टर्मिनल से ज्यादा है, मतलब दिस इज आल्सो रिवर्स बायस। बोथ द जंक्शन रिवर्स बायस। if both the junctions reverse bias means cut off region. This is in what? Cut off region, right? Then find the region of operation for this one. अब ये थोड़ा सा फास्ट आप लोग बताते जाइए। देखिए अगर आप यहां पर लगा रहे हो 2 वोल्ट, मतलब n is p base region is what? Positive. Base region is positive. This is ground. Emitter region is connected to ground. Means what about this junction? Forward bias. That this is connected to what? Minus 3 volt. This is 2 volt. Means this diode is also what? Forward bias by 5 volt. Because n is less, p is more. This junction is also forward bias. If both the junctions are forward bias, means it is in saturation region. देखिए चाहे आप एक्टिव में रखो, चाहे कट ऑफ में, चाहे सैचुरेशन में, वी आर पुटिंग बाय विद द हेल्प ऑफ व्हाट? डीसी सप्लाई। यहाँ पर हम डीसी सप्लाई से इसको मेंटेन करते हैं। देन अब आप इसका बना सकते हो। आपको यहाँ पर दिखाई दे रहा है, इसमें क्या किया? डायग्राम के डायरेक्शन। कई बार क्या होता है, बहुत ही बेसिक सा क्वेश्चन होता है, डायग्राम के ओरिएंटेशन को चेंज कर देते हैं। ओरिएंटेशन चेंज करने से भी हमको कंफ्यूजन हो जाता है कि ये कौन से रीजन में है। देखो यहाँ पर ध्यान देना, ये है एनपीआई ट्रांजिस्टर, बस इसे आपने घुमा दिया तो आपको देखना है कि ये एमिटर टर्मिनल, ये कौन सा? बेस टर्मिनल, ये कलेक्टर टर्मिनल है। देखिए बेस जो है कनेक्टेड टू व्हाट? -2 वोल्ट। एमिटर इज कनेक्टेड टू -5 वोल्ट। अभी देखो जो नेगेटिव जो एन साइड है वो लोअर वोल्टेज पे, पी साइड हायर वोल्टेज पे एज कंपेयर टू दिस, मींस दिस जंक्शन इज व्हाट? फॉरवर्ड बायस। और अब आप देखो कि कलेक्टर का है, कलेक्टर को कनेक्ट कर दिया गया है ग्राउंड से। अब आप देखो कि ये वाला जो एन है वो पी से क्या है? ज्यादा वोल्टेज से पे, 0 इज ग्रेटर देन -2 वोल्ट। दैट्स व्हाई दिस जंक्शन इज व्हाट? रिवर्स बायस। दिस इज फॉरवर्ड बायस, दैट इज रिवर्स बायस, मींस दिस बीजेटी इज इन व्हाट? एक्टिव रीजन। एक्टिव रीजन। तो ऐसे आप जजमेंट ले सकते हो, वेदर इट इज इन अ कट ऑफ रीजन, एक्टिव रीजन और व्हाट? सैचुरेशन रीजन। ये तो एकदम बिल्कुल बेसिक सा क्वेश्चन हो गया कि कैसे हमको डिसाइड करना है कि इट इज इन व्हिच रीजन, राइट? अब आते हैं जरा, जब हम लोग बात करते हैं कि ऑपरेटिंग पॉइंट को हमको सेट करना है, तो व्हाट इज द मीनिंग ऑफ द ऑपरेटिंग पॉइंट? ऑपरेटिंग पॉइंट होता है आईसी एंड व्हाट? वीसीई। आईसी वीसीई। आईसी हम लेते हैं ऑन वाई एक्सिस, वीसीई ऑन एक्स एक्सिस, एंड वी हैव टू सेट द ऑपरेटिंग पॉइंट। जैसे कि आप कैरेक्टरिस्टिक्स पढ़ते हैं बीजेटी की, तो आपको ऐसा है दिखाई देगा बीजेटी की कॉमन एमिटर की कैरेक्टरिस्टिक्स, तो हम ईडीसी में पूरा कर्व बनाते हैं। राइट? दिस पोर्शन इज कॉल्ड व्हाट? सैचुरेशन। दिस इज कॉल्ड कट ऑफ, and that is called what? Active region. From this point to this point, this is called active region. For different values of IB, we are having a different curve. For example, 20 microampere, 40 microampere, 80 microampere, 100 microampere, this is the 60, 80 and so on. 60 microampere, 80 microampere, 20, 40, 60, 80 microampere, this is the curve. In active region, as you know, the formula is given by IC is equal to beta IB, right? Beta is called the current gain. Now, that is the characteristics. यहाँ इस कैरेक्टरिस्टिक से आपको क्या इंफॉर्मेशन मिल रही है? ये जो रीजन है ना, ये सैचुरेशन रीजन। ये जो रीजन है, that is called what? Cut off region. And that region is called what? Active region. This region is called active region. फिर हम क्या करते हैं, इस पर एक ड्रॉ करते हैं डीसी लोड लाइन। जस्ट सिंपल डीसी लोड लाइन है, लाइक दिस। डीसी लोड लाइन, इसे बोला जाता है डीसी लोड लाइन। यहां पर आपके पास क्या आएगा? मैक्सिमम करंट, और यहाँ है मैक्सिमम वोल्टेज ऑफ मैक्सिमम वैल्यू ऑफ द VCE when the current is what 0. So this is called DC load line. Now when the DC load line cut particular curve, for example the base current is 40 microampere, this point is called what operating point or what Q point, operating point or Q point. Q point कौन से रीजन में होना चाहिए? अगर आप एम्प्लीफिकेशन चाहते हैं तो दैट शुड बी इन व्हाट एक्टिव रीजन, तो ये आपका एक्टिव रीजन, राइट। और एक्टिव रीजन में हमारा क्या होना चाहिए? Q पॉइंट होना चाहिए, दैट इज कॉल्ड ऑपरेटिंग पॉइंट और क्वेश्चन पॉइंट और डीसी वोल्टेज, राइट। तो ये आपका वोल्टेज एंड करंट ऑफ द ट्रांजिस्टर विद नो इनपुट सिग्नल अप्लाइड। कोई भी जब आप इनपुट सिग्नल नहीं अप्लाई कर रहे हैं तो कहां पर आपका ऑपरेटिंग पॉइंट सेट है, दैट इज कॉल्ड व्हाट Q पॉइंट। ओके, तो आपने कहां पर सेट किया हुआ है? इन द मिडिल ऑफ व्हाट एक्टिव रीजन, राइट। नाउ एक बार अगर आपने Q पॉइंट सेट कर दिया तो ये आपका Q पॉइंट हो गया। ये देखो, ये है डीसी लोड लाइन, दिस इज द Q पॉइंट, दिस इज IC। ड्रॉप द परपेंडिकुलर, यू विल गेट द वैल्यू ऑफ द ICQ, दिस इज कॉल्ड ऑपरेटिंग पॉइंट वैल्यू। ड्रॉप द परपेंडिकुलर हियर, you will get the value of what VCEQ, and operating point is called IC VCEQ। क्या आप, लेकिन देखो आप जितने भी न्यूमेरिकल्स बनाते हो ना, उसमें हम लोग ग्राफिकल एनालिसिस नहीं करते, हम क्या करते हैं? वी आर डूइंग अ न्यूमेरिकल एनालिसिस। न्यूमेरिकल्स होते हैं, न्यूमेरिकल बनाते हैं और न्यूमेरिकल से हम लोग क्या सॉल्व करते हैं? ICQ एंड व्हाट VCEQ। तो आज मैं वही आपको बताने वाला हूं फॉर डिफरेंट क्वेश्चंस हाउ वी कैन solve the ICQ and what VCEQ। तो बहुत सारे डिफरेंट डायग्राम्स हैं जिससे हम लोग Q पॉइंट को स्टेबल रखते हैं। यहाँ पर देखो, दिस टाइप ऑफ सर्किट इज कॉल्ड व्हाट फिक्स्ड बायस सर्किट, फिक्स्ड बायस्ड सर्किट। यहाँ पर ध्यान रखना, एक RB लगा हुआ है, डायरेक्ट VCC लगा हुआ है, दिस इज द RC। वी विल सॉल्व क्वेश्चन ऑन दिस। दिस टाइप ऑफ सर्किट इज कॉल्ड फिक्स्ड बायस्ड सर्किट। यहाँ पर देखो, आपको कोई RB नहीं दिखाई दे रहा है, यहाँ पे कलेक्टर और बेस के बीच में कोई कनेक्शन नहीं है। फिक्स्ड बायस सर्किट नाम जो दिया गया है वो ध्यान रखिएगा, इसमें कोई भी नेगेटिव फीडबैक नहीं है, देयर इज नो नेगेटिव फीडबैक। ओके, दैट्स व्हाई इट इज कॉल्ड व्हाट फिक्स्ड बायस्ड सर्किट। यहां देखिए, ये देखिए कलेक्टर टू बेस बायस, मतलब एक और सर्किट है, यहाँ पे कलेक्टर और बेस को कनेक्ट कर दिया है, ठीक है। कलेक्टर से क्या कनेक्टेड है? बेस कनेक्टेड है। दिस टाइप ऑफ सर्किट इज कॉल्ड व्हाट कलेक्टर बेस बायस सर्किट। कलेक्टर बेस बायस सर्किट में नेगेटिव फीडबैक, देयर इज नेगेटिव फीडबैक, इसीलिए कलेक्टर बेस बायस सर्किट का जो Q पॉइंट है दैट विल बी व्हाट स्टेबल। ये क्या होगा? स्टेबल होगा Q पॉइंट। Q पॉइंट इज स्टेबल। ओके, देन थर्ड जो डायग्राम है दैट इज कॉल्ड सेल बायस सर्किट और पोटेंशियल डिवाइडर बायस सर्किट। सेल बायस सर्किट देखो, यहाँ पर ना एक RE लगा हुआ है, ये RE प्रोवाइड करेगा नेगेटिव फीडबैक, इसको फीडबैक रजिस्टर भी बोला जाता है। ये एक RE है, किस टर्मिनल पे लगा है? एमिटर पे लगा हुआ है, समटाइम्स इट इज आल्सो कॉल्ड एमिटर बायस सर्किट। फिर क्या करते हैं? देखो, यहाँ पर एक पोटेंशियल डिवाइडर लगा हुआ है, R1 एंड R2। तो जब भी हम इस क्वेश्चन को सॉल्व करते हैं, देन विद द हेल्प ऑफ थेवेनिन्स थ्योरम, इस R1 एंड R2 को आप कन्वर्ट कर देते हो RTH एंड VTH, RTH एंड व्हाट VTH, where VTH is given by R2 upon R1 plus R2 into VCC, R2 upon R1 plus R2 into VCC, and RTH is given by R1 parallel with R2, R1 parallel with R2। तो ये देखिए, जब भी इस सर्किट को सॉल्व करना है तो हम यहाँ पर थेवेनिन्स लगाते हैं, वी अब फाइंड कर लेते हैं VTH, R2 upon R1 plus R2 into VCC और R1 parallel with R2 से RTH, and then it is very easy to solve this question। थेवेनिन्स के बाद ये बहुत ही इजी हो गया कैसे सॉल्व करना है। आपने यहाँ देखा, यहाँ पर लगा दिया VBE की वैल्यू होती है 0.7 वोल्ट, यहाँ से आ गया IC, यहाँ से आ गया व्हाट IB, and then finally we have to find what VC. तो IC and VCE ये एक ऑपरेटिंग पॉइंट सेट करते हैं, ठीक है। अभी और क्वेश्चन बनाएंगे हम लोग। इसको बोला जाता है सेल्फ बायस्ड सर्किट। यहाँ पर RE लगा हुआ है, दैट विल प्रोवाइड यू द नेगेटिव फीडबैक। अब मैंने तीन आपको सर्किट बताए, फिक्स्ड बायस सर्किट, कलेक्टर टू बेस बायस सर्किट एंड व्हाट सेल्फ बायस सर्किट और पोटेंशियल डिवाइडर बायस सर्किट। नाउ जो स्टेबिलिटी फैक्टर है S, that is the change in IC because of the change in ICO, but beta and VB kept constant। देखिए तीन चीजों के कारण आपका Q पॉइंट अफेक्ट होता है। फर्स्ट इज व्हाट टेम्परेचर। टेम्परेचर के अंदर दो चीजें आती है, एक ICO आता है रिवर्स सैचुरेशन करंट और एक आता है व्हाट VB। और फिर होता है सेकंड वन इज रिप्लेसमेंट ऑफ ट्रांजिस्टर। रिप्लेसमेंट ऑफ ट्रांजिस्टर, रिप्लेसमेंट मींस मान लो आपके सर्किट में एक ट्रांजिस्टर लगा हुआ है और ट्रांजिस्टर खराब हो गया एंड यू हैव टू रिप्लेस इट। तो जैसे ही आप रिप्लेस करोगे वहां पर जो सबसे ज्यादा इफेक्ट होता है दैट इज बीटा। बीटा इज हाईली अफेक्टेड ड्यू टू रिप्लेसमेंट ऑफ ट्रांजिस्टर। टेम्परेचर के कारण जो टेम्परेचर में वेरिएशन है उससे अफेक्ट होता है ICO। इट डबल्स फॉर एवरी 10 डिग्री राइज इन टेम्परेचर। टेम्परेचर बढ़ने से ICO बढ़ता है और टेम्परेचर बढ़ने से VB क्या होता है रिड्यूस होता है। ये सब आपके ऑपरेटिंग पॉइंट को अफेक्ट करेंगे। द Q पॉइंट अफेक्टेड ड्यू टू व्हाट टेम्परेचर एज वेल एज व्हाट रिप्लेसमेंट ऑफ व्हाट BJT। तो हम लोग डिफरेंट सर्किट बनाते हैं, फिक्स्ड बायस सर्किट जिस पर कोई फीडबैक नहीं, कोई नेगेटिव फीडबैक नहीं, तो Q पॉइंट स्टेबल नहीं है। तो अगर आपसे इंटरव्यू में क्वेश्चन पूछा जाए कि फिक्स्ड बायस में तो कोई नेगेटिव फीडबैक नहीं है, वो सर्किट स्टेबल नहीं है, तो क्या इसे यूज करना चाहिए, यस और नो? तो ज्यादातर बच्चों का जवाब होगा नहीं सर नहीं करना चाहिए बिकॉज इट इज नॉट स्टेबल। लेकिन ध्यान रखो जब भी आप नेगेटिव फीडबैक लगाते हो ना, सर्किट का गेन रिड्यूस हो जाता है, राइट, और नंबर ऑफ कंपोनेंट्स बढ़ जाते हैं। देखो ये इतना सिंपल सा सर्किट है RB और RC। यहाँ देखो जैसे ही आपने फीडबैक लगाया सप्लाई आपको बढ़ाना पड़ेगा क्योंकि एक्स्ट्रा आपका नेगेटिव फीडबैक के कारण सिस्टम का गेन क्या हो जाएगा, कम हो जाएगा। यहाँ देखो एक्स्ट्रा कंपोनेंट लगाना पड़ रहा है RE R1 R2, सप्लाई आपको इंक्रीज करनी पड़ेगी क्योंकि गेन आपको क्या हो जाएगा रिड्यूस हो जाएगा। तो जहां भी आपको लगता है फिक्स्ड बायस सर्किट जहां पर टेम्परेचर में वेरिएशन ज्यादा नहीं है वहां पर आपको सर्किट को क्या यूज करना चाहिए, राइट, you have to use what circuit in fixed bias mode, right? Now this is a character based bias circuit and that is what potential divider bias circuit. Now what about the stability factor? Stability factor, when I am talking about the stability factor, the range of the stability factor S, change in IC because of change in ICO, S is equal to 1 plus beta when there is no negative feedback. No negative feedback means Q point is not stable. It is the highest value of S. S less than 1 plus beta. Q point is stable. Q point is stable. Or when the S is equal to 1, lowest value of the S, then it is called highly stable. Q point is highly stable. Always remember when value of S decreases, guys, stability increases. Stability increases. What is the lowest value of the stability factor? 1. And what is the highest value of the stability factor? 1 plus beta. And when we are giving the negative feedback, the stability factor will reduce. The lowest value is what? 1. Lowest value is 1. Now are you ready to solve some questions on this topic? चलिए आइए क्वेश्चन बनाते हैं. Now first question. Find IC and VC. Please read question carefully. IC and VC. VC means collector terminal voltage. This is the collector terminal voltage, right? In this case, emitter is connected to ground. So what is the VCE? VC minus VE. What is the VE? Connected to ground, and that's why it is VC minus 0. So that is nothing but VC. In particular case, VC is equal to what? VCE, right? Second, this is IC. IC and VCE are called operating point. You have to find the operating point. Assume the VB 0.7 volt, beta is equal to 100. For silicon transistor, it is an NPN transistor, and for silicon transistor, value of the VBE is what? 0.7 volt. So everyone, please share the link of this session so that student will join, right? And we are now going to solve some important numericals. Continuously, we are going to solve some numericals. So everyone, use your virtual calculator just to get the answer for all these questions. Okay. Now, first question. VB 0.7 beta 100. Remember, always find IB. This is what 0.7 volt. We are assuming like the BJT in what active region. So this is 0.7 volt. This is the 20 volt. So what is the value of the IB? IB will become 20 minus 0.7 upon 200. That is 19.3 upon 200. This is in kilo ohm, that's why it is in million. Now, what is the IC? IC is equal to beta IB in active region. Beta IB in active region, it is multiplied with the 100, 19.3 divided by 200, and then 19.3 divided by 2. It will become 9.6, right? 5 milliampere. 9.65 milliampere. This is the value of current. 9.65 milliampere. We have in two options. 9.65 milliampere. Okay. Now, what is the value of VC? VC is given by 20 minus. This is called VCC minus IC into RC. This is called RC and this is called VCC. 20 minus 9.65 into what? 1. 20 minus 9.65, you will get 10.35. I think now everything is fine. Sorry for some technical issues. Okay. Now, अब देखिए जरा, ये तो हो गया फर्स्ट क्वेश्चन. देन find the current IC given VB is 0.71. This time we are using the collector based bias circuit. What is the collector based bias circuit? Collector is connected to what? Base. Collector is connected to base, guys. Now, for this type of circuit, what is asked here? What is the current IC? So current IC, then first of all, remember this is the collector terminal, guys. So collector terminal, this current is IC. So number of students are writing this is IC. No, this is IC. Current enter through the collector terminal is IC. Current from this side is the base current IB. Base current IB. So this is IB. This is IC. So what is the current here? IC plus IB. IC plus IB. And what is this? VBE. VBE. Now, if the transistor is in active region, then IC is given by beta IB. Then remember, IC plus IB. You can write beta plus 1 times of IB. Beta plus 1 times of IB in active region only, because this formula is valid for active region. So what is the value of the beta here? 50 it is given in the question. So 51 times of IB. 51 times of IB. Now in one step you can write the KVL here. This is the 15 is equal to IC plus IB is 51 times of IB into RC. So 51 times of IB into 1. Now 200 times of IB. 200 times of IB plus 0.7. What is the value of the VB? 0.7. It is given in the question, 0.7. Now, what is the value of the IB here? 15 minus 0.7 divided by 251. Milliampere. Milliampere, right? With the help of virtual calculator you can find. Now, what is the IC? IC is beta times of IB. IC is nothing but beta times of IB. You can write beta. What is the beta? 50 into 14.3 divided by 250. Nearly equal to 250, or just for calculation this is what 5, or 14.3 means it is become 2.86, nearly equal to 2.86 milliampere. Which answer? 2.84. So yes, because just I have taken what 251 as a 250, and that's why the answer will be less than that. So here again calculation without using the calculator. Okay, so this is the value. Which value? D, 2.84. 2.84 is the value of the current. Now remember, in this case no need to check the VCE. Why? Because for active region VCE should be greater than what VCE is set. Normally what is the value of the VCE set? 0.2 volt for silicon, or otherwise in particular question they will mention what is the value of VCE set, right? Is it clear? Is it audible? Everything is fine now? Okay. Then guys, in this particular question no need to check. Why? Simple. Watch this question. What is VCE? This current is IB. This current voltage is what? VB, that is 0.7. You can write the KVL from this point to this point in this loop. So when you are going to write the KVL, it will become minus VCE this is the minus VCE plus 200 times of IB plus VBE is equal to 0. So what is the value of the VCE? VBE plus 200 times of IB. IB is positive, VBE is positive. This is the 0.7 plus 200 times of IB. Guys, it is always greater than what? 0.2 volt. Because it is 0.7 plus something. So no need to check. So when the collector is connected to base, definitely the transistor will be in what? Active region. It is not in saturation region. If you are giving the sufficient voltage, it will be in active region. That's why no need to find the value of VC just to verify whether it is in active region or saturation region. Direct आप बता सकते हो it is in active region. तो answer for this question is 2.84. Okay. देखिए, first question I have solved simple fixed bias circuit. Second collector based bias circuit. Now third question. This is on what? Self biased circuit. तो systematic ढंग से एक एक क्वेश्चन सॉल्व कीजिए, आपको आइडिया लग जाएगा कैसे क्वेश्चन सॉल्व करना है. सेल्फ बायस्ड सर्किट. सेल्फ बायस्ड सर्किट में आपको क्या करना है? दैट इज द वैल्यू IC and VCE. VB 0.6 volt. Read question carefully. This time the VB is 0.6 volt. Beta is given as 150. You have to find the IC and VCE. Okay. Then for this type of questions, अच्छा आप लोग भी सॉल्व कीजिए and try to give me the answer. Use your virtual calculator. Okay. Which answer is correct? Option A, option B, option C or option D? Just like a mock test. Okay. So this is a self-biased circuit. RE is connected. This is called RE. This is RC. This is R1. This is R2. And that is called VCC. Just to find the value of IC and VC, apply the Thevenin's. But here, then find the VTH. VTH is R2 upon R1 plus R2 into VCC 20 volt. That is the 4 volt. And what is the RTH? RTH is nothing but 1 and 4 are in parallel. 4 divided by 5. Now, you can apply RTH. 4 divided by 5 means 0.8 kilo ohm. VTH is nothing but 4 volt. This is RE 1 kilo ohm and that is RC 1 kilo ohm. And this is the 20 volt. Now first of all find this one. Then this is IB here. This is IC. This current is what? IC. So what is the current here? IC plus IB. Or in active region, IC plus IB is written as 1 plus beta times of IB. In active region, because IC is equal to beta IB. So what is the IB? What is the beta? 150. That's why it will become 151 times of what? IB. 151 times of IB. Now this voltage VB, in question it is given VB is 0.6 volt. Now write down the KVL from this point to this point and just find the IB. So what is the value? 4 is equal to, just write down the KVL. 4, this is the VBB, is equal to 0.8 times of IB plus 151 times of IB into 1 kilo ohm. 151 times of IB into 1 kilo ohm plus what? 0.6 volt. Plus 0.6, that is the value of the VB. So what is the IB? 4 minus 0.6 upon 151.8. Now you can find the value of IB. Calculate it and give me the answer. Now once you have the IB, you can find the IC. What is the IC? Is equal to 150 beta times of IB. 150 beta times of IB. IC is equal to. अब फाइंड कर लो. लेकिन व्हाट इज द वैल्यू ऑफ व्हाट VCE? VCE, how we can find the value of the VCE, guys? So just to find the value of the VCE, remember this is the value of VCE. This is VCE. First of all, find the value of IB, then find the value of IC, then finally VCE. VCE means you have to write the KVL from this point to this point. Remember, from this point to this point. So what is the KVL here? Just to find the VCE, this is given by 20 is equal to IC into what? 1 kilo ohm, that is called RC, plus VCE, this is the VCE, plus IC into RE. Or you can say there is a two currents, IB and IC. So you have to write IB plus IC into what? RE. IC plus IB into RE. You can also neglect the IB in comparison to what? IC, because IC is equal to what? Beta times of IB. IC is equal to beta times of IB, that is 150 times of IB. So this is very greater than what IB. So you can neglect what IB here. And then what VC will become 20 minus IC times of RC plus RE. Now remember this formula. 20 minus IC into RC plus RE. RC RE 2 1 plus 1 2 kilo ohm, or already you have calculated the IC 150 times of IB. Yes. So you will get the answer for this particular question, guys. तो जल्दी से बता दीजिए कौन सा आंसर आ रहा है. 3.37, 13.24, 10 मिली एम्पियर, 1.2 मिली एम्पियर. अब आप यहाँ पर देखोगे ना, तो आपको सभी आंसर एक तो अलग अलग दिखाई दे रहे हैं. तो एक ही बार में आप आंसर निकाल सकते हो. आईसी की वैल्यू बस निकाल लीजिए एंड यू विल गेट द राइट आंसर. बताओ क्या आ रहा है आंसर. सबसे पहले ध्यान दीजिएगा, दैट इज द 3.4 अपॉन 151.8, 0.022. very small what? Current, base current. Then it is multiplied with the 3.35 9, मतलब we can say 3.36 milliampere. Is there any 3.36 milliampere? Just 3.37, nearly equal to 3.37 milliampere, 13.24. Now 3.37, 20 minus this is 2, so 3.37 into 2, around 13.28. So 13.24, this is the answer for this question is A. तो होप आपको आइडिया लग गया कलेक्टर बेस्ड बायस सर्किट कैसे सॉल्व करना है, सेल बायस सर्किट कैसे सॉल्व करना है. तो ये देखो पहला बेसिक क्वेश्चन, फिक्स्ड बायस सर्किट, very simple. Then second question, collector based bias circuit, no need to check whether it is in active region, yes or no, then always in active region. Then third one is what? Cell bias circuit, by using the potential divider. Divide it, find the Thevenin's equivalent. Then देखो जब भी बीटा इज ना, बीटा इज very large, guys. If the beta is very large, so normally what we are doing in gate exam, approximated answer means you can neglect the base current. Just I am going to neglecting the base current, then what will be the answer? So then if you are going to neglecting the base current, this is 1 kilo ohm, this is 1 kilo ohm. Since the beta is very large, then no need to find the RTH. Simply find the VTH only. VTH means simple. What is the VTH? 1 divided by 1 plus 4 into 20. 1 divided by 1 plus 4 into 20. That is the 4 volt. No need to find the RTH. Why? Because we are just neglecting the IB. We are just taking the IB is nearly equal to 0. What is this voltage? 0.6 volt. This is IC. This is IC. Because we are neglecting. In one step you can write KVL. 4 is equal to, because base current is 0, 0.6 plus IC into 1. What is the IC is equal to? 4 minus 0.6 upon 1. That will become 3.4 milliampere. 3.4 milliampere. So in exact analysis, what is our IC? 3.359. Or not nearly equal to, we are getting what? 3.4. Overestimated. Overestimated means थोड़ा ज़्यादा आ रहा है, चलेगा 3.4. Then second thing, once you have the 3.4, what is the value of the VCE? VCE will become 20 minus IC into RC plus RE. क्या करना है? 20 minus drop across the RC, drop across the RE. So it will become 20 minus 2 into 3.4, because it is 2, 1 plus 1, 2 and 3.4. 20 minus 6.8, and now you can find 13.2. 13.2 और exact कितना आ रहा था भाई? 13.24. So it is underestimated. Why underestimated? Because we are calculating current IC overestimated. When the current increases, VC will decrease. So we are getting the nearby that answer. Okay. तो यहां पर ऐसा है, because the base beta is very very large, you can neglect the base current. Then calculation is very very easy. So normally beta is very very large, you can neglect the base current and you will get the answer. In GATE exam, we are getting this type of questions. Normally we have to neglect the base current. I think that is clear to you. Cell bias circuit. Cell bias circuit. Up to this point, any doubt? Then yes, you can ask. Everyone, for any detail about the courses, you can message me on that number 9899940096. Now you can join topic wise. For example, if you want to get the command over operational amplifier, or what BJT, or what MOSFET, or Thevenin's theorem, or two-port network. So topic wise you can also join. Short duration, but the validity is only for 30 days. This is for GATE 2025, right? तो आप यहाँ पर कॉल कीजिए, मैसेज कीजिए. I will give you all the information. Start your preparation now. Most important thing, personal guidance, right? जो भी आपको डाउट्स आ रहा है वो डाउट्स अपने क्लियर कीजिए. कैसे प्रिपरेशन करनी है, इस बार आपके लिए गोल्डन अपॉर्चुनिटी है. दैट इज इंजीनियरिंग सर्विसेज एग्जाम, IRMS, Indian Railway Management Service, guys. Okay. Now sometimes we have to find what different voltages, like find the VE. VE means emitter terminal voltage, right? Emitter terminal voltage means this is the emitter terminal voltage. This is the emitter and that is the emitter terminal voltage only with respect to what? Ground. So don't worry about this type of questions. RE is connected here. This is the 2 kilo ohm. It is also, we can say it is a, when the RE is connected, this is called emitter bias circuit. We are not connecting the potential divider here. So this is the emitter resistor is connected. So simply it is a emitter biased circuit, right? Emitter biased circuit. Now, अब कैसे निकाले emitter V? Very simple. This is the IC. This is IB. What is the current here? IC plus IB. We are assuming like it is in what? Active region. So IC plus what? IB. What is the beta? 100. So IC plus IB will become 1 plus beta times of IB. 101 times of IB. If you want to find the voltage at this point, this is nothing but 101 IB into what? 1 kilo ohm. Then write down the KVL from this point to this point. So when we are writing the KVL from this side to this side, this is VBE. What is the value of the VBE given in the question? 0.7. तो बिल्कुल घबराना नहीं, इलेक्ट्रिकल में ऐसे ही क्वेश्चन चाहिए। 20 वोल्ट इज इक्वल टू IB इंटू 400 IB प्लस 0.7 VBE plus 101 times of IB into 1 kilo ohm. This is the 1 kilo ohm. Then IB is equal to 20 minus 0.7 upon 501 milliampere. Right, 501 milliampere. Now you have to find the value of the V. V means voltage at emitter terminal is nothing but 101 IB into what? 1 kilo ohm. That is nothing but RE. You can write IE into RE. What is the IE? 1 plus beta times of IB into RE. This is the emitter current. Emitter current is given by 1 plus beta times of IB. This is the emitter current, IE. Then this will become 101 into, what is the IB? 19.3 upon 501 into what? 1 kilo ohm. Yeah, calculation. Use your virtual calculator. So this is a 3.89 volt. This is one. 3.89 volt. लेकिन remember guys, in exam you have to verify whether it is in active region, yes or no. So how we can find out whether it is in active region or yes or no? This is the 3.89. Now what is the value of the VC? So VCE means what? VC minus VE. That should be greater than what? 0.2 volt. What should be the value of the VC? That should be greater than what? 0.2 plus VE. What is the V? 3.89 plus 0.2. Right? So yes, to find the value of the VC. How we can find the value of VC? VC is equal to 20 minus IC into RC into 2 kilo ohm. And what is the IC? Beta times of what? IB. Beta times of IB. Beta is 100 and what is the IB? IB, we have calculated the IB. 19.3 upon 501. 501. You have to verify. In exam, please verify it. Otherwise, you will get the wrong answer. Whether it is in active region, yes or no. Now, $12.29. Definitely it is greater than this value. Greater than this value, right? VC plus V. This will become, this is the 0.2 volt, na? So 4.09. Yes, it is greater than 4.09 volt. That's why it is in active region. So हमेशा verify करो whether it is in active region. Yes, that answer is correct. 3.89. 3.89. तो होप आप आपसे ऐसे क्वेश्चंस बन जाएंगे. टेल मी. नाउ समटाइम्स आपको ना दो ट्रांजिस्टर कनेक्टेड दिखाई देंगे. दीज आर द सर्किट. 2 transistors are connected here. First one, second one. 5 kilo ohm, 1.5 kilo ohm, 1 kilo ohm. This is called potential divider circuit. 5 kilo ohm, R1, R2, R3. Then this is the RE, 1 kilo ohm is connected, 2 kilo ohm it is connected. Find the value of the VC if VB is 0.3 volt only. VBE is given as 0.3 volt. So this type of potential divider circuit, guys. Potential divider. Beta is given in the question? No. If the beta is not given in the question, what is the value of the beta? Very, very, very greater than 1. Very large. When the beta is very, very large, what is the base current? Negligible. So what is the collector current? Is nearly equal to what? Emitter current. Both are equal. Because the base current is what? Negligible. Base current is negligible. Now, how we can solve this question? Find the value of the VC. Now, watch this. This is the 5 kilo ohm resistor, 1.5 kilo ohm, 1 kilo ohm resistor. This is the 1 kilo ohm resistor. The VB value is what? 0.3. That is always normally by default what we are taking 0.7 volt. But what is given in the question? 0.2 volt. 0.3 volt. So this is a question. This is 0.3 volt. This is 0.3 volt. This current IC, what is the base current? 0. That's why same current flow here, same current flow here. IC, 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 IC. Why? Because the base current is negligible, beta is very, very large. Now, how we can find the IC? First of all, find the voltage at this point. If you have the voltage at this point, you can apply the KVL here. You can apply the KVL in this loop and you can find the IC. Then once you have the IC, you can find the value of the VC. VC is nothing but 10 minus IC into 2 kilo ohm. That is the equation number 1. So VC. So you have to find the IC. Just now, if you want to find the value of IC, find the voltage at this point. Let this voltage is what? V1. Let this is the transistor number 1. This is the transistor number 2. So this is the V2. According to potential divider rule, because there is no current, you can cut here. This is R1, this is R2, this is R3. We have to find the voltage at this point, and this is the 10 volt. R1, R2, R3. Now tell me, what is the voltage at this point? V1 is equal to R3 upon R1 plus R2 plus R3 into what? VCC. VCC means this is the 10 volt. R3 1 kilo ohm upon 5 plus 1.5 plus 1 into 1 into what? 10 volt. That will become 6.5, 7.5, 10 divided by 7.5, 4 by 3. 4 by 3 milliampere. That is the current here. That is the voltage at this point. Now, once you have the voltage at this point, right, no need to find the RTH. Why? Because the base current is negligible. No need to find the RTH. Once you have the voltage at this point, then directly at this point, what was the voltage? 4 by 3. This is not milliampere, that is the volt. That is what? Volt. Now, write down the KVL. This is the 4 by 3 volt. So, 4 by 3 is equal to 0.3, that is the VB, plus IC into 1 kilo ohm. IC into 1 kilo ohm. So, what is the IC? 4 by 3, that is the points 4 by 3 minus 0.3 divided by 1. Now, directly you can find. Tell me what is the answer? 4 by 3 1.033. This is the milliampere. This is the value of the current. Now, once you have the value of the IC, what is the value of the VC? 10 minus 2 times of IC. This is multiplied with the 2 and minus 10. 7.933. 7.933 नियरली इक्वल टू 8 वोल्ट। देखो जब आप आंसर देखो, दिस ऑल आर द अप्रोक्सीमेटेड आंसर, नियरली इक्वल टू व्हाट 8 वोल्ट। तो क्विकली यू कैन सॉल्व गाइस, क्विकली फर्स्ट ऑफ ऑल फाइंड द वोल्टेज एट दिस पॉइंट। देखो on the diagram itself, no need to redraw the diagram. 1 divided by 5 plus 1.5, 6.5 plus 7.5 into what 10, that is nothing but 10 divided by 4 by 3 volt, right? 2.5 divided by that, 4 divided by 3, this is the voltage at 4 by 3, 0.3. IC directly you can write IC is equal to 4 by 3 minus 0.3 upon what 1 kilo ohm. This will become 1.03 milliampere. Now what is the value of the VC? VC is equal to 10 minus 2 times of IC, nearly equal to what 8 volt. So this is a standard circuit. अगर आपको ये क्वेश्चन आ रहा है, then directly find the voltage at this point, base current is negligible, and then find the value of IC, then apply the question, right? तो ये ऐसा आप बना सकते हो, ठीक है। then next one, अब आते दोस्तों ये तो different types of biasing. Biasing means potential divider we are using, we are connecting the two transistors, and then potential divider we have to find the current, we have to find the voltage at different terminals, collector terminal, emitter terminal, base terminal. फिर आता है एक और सर्किट है जिससे आप लोगों को बनाना होता है, दैट इज कॉल्ड करंट मिरर सर्किट। करंट मिरर सर्किट वो भी है, देखिए दिस इज द बेसिक करंट मिरर। करंट मिरर मींस द आउटपुट करंट, दिस इज द फोर्स टू इक्वल द इनपुट करंट। आउटपुट करंट इज फोर्स्ड टू इक्वल द इनपुट करंट, एंड दिस टाइप ऑफ सर्किट इज कॉल्ड व्हाट करंट मिरर सर्किट गाइस। तो करंट मिरर सर्किट IC2 is equal to what I1, that is I1 is called reference current. This is the basic diagram of the current mirror circuit. Normally what is the condition? Beta should be very very large. Beta, normally beta it is in the range of what 1000 for current mirror circuit. Beta should be very very large. Then we are saying that both the transistors should be identical. Then IC2 is equal to, or output current is forced to equal the input current. So this is the reference current divided by 1 plus 2 by beta. Actual formula is this one. Actual formula is this one. If both the transistors are identical, if both the transistors are identical, beta same, every characteristics is same, then you can write like this. Characteristics same, everything is same, then the actual formula, the output current in terms of input current is given by I1 upon 1 plus 2 by beta. But the beta is very very large, then it is nearly equal to what I1. Then 2 by beta is very very less than 1. This is the I1. Now how we can find the I1? Always remember this voltage is what VB. In parallel we have the same voltage VB here. So you can write the KVL from this point to this point, and then you can find the value of what I1. 0 is equal to I1 R1 plus VB minus VE. देखो यहाँ पर बैटरी लगी है -V, और sometimes we have battery connected here. So what is the value of I1 is equal to VEE minus VBE upon what I1? Upon R1. Find the value of I1, and that is the value of what I0. Simple current mirror circuit. I think now all are ready to solve some questions on current mirror circuit. So we have solved questions on fixed bias, collector based bias, cell bias circuit, biasing and stabilization. Now current mirror circuit guys, current mirror circuit. Now tell me what is the answer for this one. In the current mirror shown, IC1 is equal to 1 milliampere. Already given IC1 is equal to 1 milliampere. VB is 0.7 volt. The value of R is, means beta is not given. Beta is not given. If the beta is not given means what? Beta is very very large. Beta is very very large. So tell me what is the answer for this particular question. Very high means Raj, in case of current mirror circuit, we are taking beta 1000, 700, 900. Or in case of normal BJT amplifier, if the beta is more than 100, then you can consider it what large, 150, 100. In case of amplifier, 100 and 150 is a large value. But in case of current mirror, it is more than 1000. Then we can consider it what large. Otherwise, you have to use this formula. This one. 1 plus 2 by beta. Now, okay, IC is equal to 1 milliampere, it is given. Beta is not given, means beta is very, very large. So I reference and IC are equal. So what is the I reference? I reference is nothing but 10 minus VB. This is 10 minus VB upon what R? Now you have to find the value of R. So R will become 10 minus 0.7 upon I reference. What is the I reference? It is equal to 1 milliampere. So that is the 9.3 divided by 1 milliampere. It will become 9.3 kilo ohm. 9.3 kilo ohm. Okay. So simple answer 9.3 kilo ohm. तो वही है आई रेफरेंस का जो फॉर्मूला है, आई दिया हुआ है, दोनों इक्वल होते हैं. अगर आपने क्वेश्चन को घुमा दिया तो आप आर की वैल्यू भी फाइंड कर सकते हो 9.3 किलो ओम. यह है एक क्वेश्चन करंट मिरर सर्किट पर, ऑन द करंट मिरर सर्किट गाइस. देखो अभी आया था जो प्रीवियस ईयर क्वेश्चन है, इफ द बीटा इज 100. देखो बीटा इज नॉट टू हाई, बीटा इज 100 ओनली. बीटा इज व्हाट 100. So in a current mirror circuit, we are using the 500 or 1000, but it is only 100. Find the value of VCE1. Where is the VCE1? This is the transistor T2, that is the transistor T1. So definitely this is the VCE1. VCE1 means we have to find the voltage at this terminal. So you have to find the current at this point. And now always remember, if this is connected here, so this is the driver and that is the load. So here we will have to find the I reference. This point is connected here. Now this is 0.7 volt. VB, the value of the VB is not given, means 0.7 volt. By default it is 0.7 volt. Now you can write the KVL from this point to this point. You can find the value of the I reference. From I reference you can find the value of what I1. But beta, what is the beta? 100 is given, not too high. So you have to use what? Formula, exact formula. What is the exact formula? I0 is equal to I reference divided by 1 plus 2 by beta. Now just to find the I reference, write down the KVL from this point to this point. It will become 12 is equal to 10 times of I reference plus 0.7. So what is the I reference will become 12 minus 0.7 divided by 10, that is 1.13. 1.13, then it will become 1.13 divided by 1 plus 2 by 100. 1.13 divided by 1.02. 1.02. This is the exact value. So what is the voltage at this point? This is called VC or VCE because VE is connected to ground. So VCE is nothing but VC minus VE. This is equal to what? VC. Why? Because VE is 0. 50 minus 20 times of I0. 50 minus 20 times of I0. 50 minus 20 times of, what is the I0? 1.13 divided by 1.02. Because in a numerical answer type question you have to find the exact value, तो बिल्कुल use करो वैसा. क्या आएगा बोलो? 1.13 डिवाइडेड बाई 1.02 इंटू 20 माइनस 50, 27.84. 27.84. This is the 27.84. Yes, please. Normally देखो राज, in a particular question if the beta is not given you have to consider it what large. Okay, otherwise if the beta is given you have to consider it, for example 30 or 50 or 100. But if the beta is given in the range of what 150, that is too large, then you can neglect what base current. Okay, so normally in a particular question beta is not given, means you have to consider it very very large, and it also depends upon the value of the registers and so on. इसीलिए बार बार क्वेश्चंस बना रहे हैं, देखो क्वेश्चन के साथ साथ वेरीफाई करो, अलग अलग क्वेश्चन में अलग अलग जगह कंसीडर करना है नहीं करना है. This question is clear everyone? Now watch this question, that current is independent of the value of the load, because this I1 is equal to what? I reference, and it is independent of the value of the load. Whether it is a resistor, inductor or capacitor, current will remain same. That is a constant current. That is a constant current, guys. And this is called current mirror circuit. Current mirror circuit. और भी बनाएंगे, और भी number of questions on current mirror circuit. Now, watch last question. Then we will solve some questions from what competitive previous year question paper. Okay. Then two perfectly matched transistors are connected as shown. Beta is very very large. Junction voltage is 0.7 volt. Find I. Beta is very large. Junction voltage is 0.7 volt. Find I. Now remember, if orientation change, this collector is connected to base, means it is a driver circuit. And that is, here we are getting the output current. Here it is a output current I0. So what is this? This is the I reference, guys. Always remember, this is the I reference. We have just changed the orientation. So if you are watching the recorded session, first of all stop the session, then try to solve, then watch the answer. What is the drop across the diode? Perfectly matched transistors are connected and so junction voltage is what? 0.7. Junction voltage is 0.7, means there are two junctions. One is the PN junction, one is the emitter junction. This is a silicon diode, silicon transistor, then junction voltage is what? 0.7 volt, 0.7 volt. So for 0.7 volt here, 0.7 volt here. Now you have to write the KVL from this point to this point. KVL. Just to find the I reference. So don't worry about the orientation. Write down the KVL from this point to this point. So this is the value. 0 is equal to I reference into 1. This is the I reference into 1 plus what is the drop across the diode? 0.7 volt plus this is the 0.7 volt VB minus 5 volt. This is the battery minus 5 volt. So what is the I reference will become 5 minus 1.4 upon 1, 3.6 milliampere. 3.6 milliampere. Since the beta is very very large, and that's why I1 will become 3.6 milliampere. Output current is forced to equal the input current. तो आपको ये ध्यान रखना है कहां कलेक्टर और बेस कनेक्टेड है, वो आपका आई रेफरेंस देगा और इधर आपका आएगा व्हाट? आई नॉट, आई रेफरेंस. तो थोड़ा सा ओरिएंटेशन चेंज करता है तो कई लोग कंफ्यूज हो जाते हैं. डोंट वरी अबाउट दैट. दिस इज द क्वेश्चन. 3.6 milliampere. दिस इज द आंसर. 3.6 milliampere. ओके. तो यहां पर डायोड क्या कर रहा है पता? डायोड इज प्रोवाइडिंग एक्स्ट्रा 0.7 वोल्ट, इज अपोजिंग दिस वोल्टेज. and that's why the value of the current reduces. If suppose there is no diode, for example, there is no diode, then what will be the current? 5 minus 0.7 upon 1, 4.3 milliampere. Without diode, 5 minus 0.7 upon what 1, that is what 4.3 milliampere. We are getting this much current. With diode, we are getting 3.6 milliampere. So what is the role of the diode? Just to reduce the value of current. Just to reduce the value of current. That is the C. C is the answer. Now, so this is about the, already we have learned about what biasing. Then we have learned about what current mirror circuit. Now amplification. What is the amplification? What is the role of the hybrid model, pi model, RE model? Okay, so amplification. For amplification, guys, just simple, watch this. We are giving the small signal. When we are talking about the small signal as compared to DC, this is a very small. Small means, for example, you are giving the supply voltage in BJT, for example, 10 volt. And what is this signal? Sinusoidal signal, 0.1 sine omega t volt. So what is the amplitude? Only 0.1 volt. So what about the 0.1 volt? Very less as compared to DC. And that's why this DC is called large signal and this is called small signal. And that's why this complete analysis is called what? Small signal analysis. Just to maintain the linearity. So it is a BJT or MOSFET. When we are giving the input, the swing of the input increases. But the shape will remain same. Suppose we are giving the sinusoidal signal, we have to get the sinusoidal signal. Square wave, output should be square wave. Triangular wave. Shape of the output should be same or similar to what? Shape of the input. Then it is called distortionless output. If suppose there is a different shapes we are getting, then it is called distorted output. तो आपको अगर आउटपुट चाहिए तो आउटपुट का शेप और इनपुट का शेप सेम होना चाहिए. But what about the swing increases? Swing increases means signal get amplified. If the swing increases, swing means maximum minus minimum. Vmax minus Vmin. Maximum minus minimum, that is called swing. If the swing increases means power increases. So always remember, for amplification, power of the output signal should be greater than the power of the input signal. Power of the output signal should be greater than the power of the input signal. तो क्या आप बता सकते हो? What about the transformer? Is it an amplifier? For example, this is the transformer. The turn ratio is 1:10. This is the voltage V1, this is the voltage V2. So V2 by V1 is equal to N2 by N1 is equal to 10 by 1. That's why the V2 is 10 times of V1. Is it an amplification? Yes or no? Output voltage is 10 times of the input voltage. क्या ये एम्पलीफायर है? यस और नो? जल्दी से कमेंट्स कीजिए. क्या ये एक एम्पलीफायर है? Is it an amplifier? तो आप बोल सकते हो यस सर, वोल्टेज तो इंक्रीज हुआ है 10 टाइम्स ऑफ V1. 10 टाइम्स ऑफ V1. नॉट एन एम्पलीफायर. व्हाई? वोल्टेज तो इंक्रीज हुआ है, लेकिन अगर आप करंट का देखोगे रेशियो, तो I2 अपॉन I1 इज इक्वल टू व्हाट? N1 बाई N2. 1 by 10. So I2 will become I1 upon 10. There is a step up in voltage, then step down in what? Current. Current will reduce. What about the under ideal transformer? V1 I1 is equal to what? V2 I2. Power at the output and power at the input will remain same. Output power is equal to what? Input power. And that's why there is no gain. So what is the gain or what is the amplification? Means power of the output should be greater than the power of the output. Yes, बिल्कुल सही बोल रहे हैं. Input power और output power same है राज. And that's why it is not an amplifier. ये amplifier नहीं है transformer. Right? तो amplification के लिए क्या जरूरी है? That power of the output should be greater than the power of input. First thing. और उसके बाद it may possible that current at the output is greater than current at the input, voltage at the output is greater than voltage at the input, or it may possible both voltage or current at the output is greater than voltage or current at the input. Right? Overall power, we have to check the power. Power should be greater than that. Right? So that is the amplification. Now we have the different types of BJT amplifiers. BJT amplifier means, for example, if the input is given to what emitter, output from the collector. So which terminal is common between input and output? Base. It is called common base. Common base. Then input is given to base, output is taken from collector. Which terminal is common to input and output? Emitter. This is called common emitter configuration. Input means we are giving the sinusoidal signal like this, and we are getting the output from this. We are getting the output from this. Then if you are giving the input to the base and output from what? Emitter. Which terminal is common between input and output? Collector. Then this type of configuration is called common collector. Common collector. Remember guys, if you are enjoying the session, like the session. First thing. Second thing, tomorrow we have session on what? Operational amplifier. Complete session on operational amplifier. So subscribe the channel so that everyone get the notification. And if you want to join topic wise courses, then available on the app, so you can join. Quick revision in systematic manner. आपको अगर एक एक चीज पता करना है, बेसिक से पढ़ना है, रिकॉर्डेड है, इसलिए आप 1.5 की स्पीड में, 2 की स्पीड में देख सकते हो. आप नोट्स बनाओ थोड़े प्रॉपर तरीके से. राइट? अब देखते हैं. तो देखो, ये 3 कॉन्फ़िगरेशन है: कॉमन बेस, कॉमन एमिटर, कॉमन कलेक्टर. वो डिसाइड होता है कि आप किस टर्मिनल पर इनपुट दे रहे हो और कहां से आउटपुट ले रहे हो. बेस पर इनपुट ले रहे हो, एमिटर से आउटपुट ले रहे हो. कॉमन कलेक्टर. राइट? Why we are using the different types of configuration? Why? They all the transistor have the different properties. What are the properties? Just I am going to explain you. So there are 3 configuration guys. देखो, अगर आपको PDF चाहिए then join my Telegram channel or otherwise I will upload on that app. तो app download कर लो, आपको लिंक मिल जाएगा. देखो, different configuration है. Common collector, common emitter, common collector and what? Common base. अब डिफरेंट कॉन्फ़िगरेशन यूज करने की जरूरत ही क्या है? एक ही से काम चल जाता. भैया हमारी नीड अलग अलग है. नीड क्या है? वोल्टेज गेन क्या होना चाहिए, करंट गेन क्या होना चाहिए, इनपुट रेजिस्टेंस क्या होना चाहिए, आउटपुट रेजिस्टेंस क्या होना चाहिए, पावर गेन क्या होना चाहिए, फेज शिफ्ट क्या होना चाहिए. डिफरेंट टाइप्स ऑफ एप्लीकेशंस हैं. तो पता है, जो कॉमन एमिटर है ना, कॉमन एमिटर में सब मॉडरेट है. मॉडरेट मतलब कई बार हाई लिखा रहेगा, हाई बहुत ज्यादा हाई नहीं है. दे ऑल आर मॉडरेट. मॉडरेट, ना ज्यादा लो है ना ज्यादा हाई है. नॉट टू हाई नॉट टू लो, इट इज मॉडरेट. बट द पावर गेन इज हाईएस्ट. In case of common emitter, power gain, that is nothing but product of what? AV into AI. This is highest. Phase shift is 180 degree. What is the meaning that phase shift is 180 degree? 180 degree phase shift means, watch it carefully. We are giving signal like this. If you are getting positive for positive and negative for negative after amplification, then it is called 0 degree phase shift. But for positive you are getting the negative, and for negative you are getting the positive. No doubt it is an amplified version, but reverse. Then it is called 180 degree phase shift. In common emitter we are getting the 180 degree phase shift. Or in common base and common collector we are getting the 0 degree phase shift. 0 degree phase shift, guys. Okay. So what is the property of the common emitter? We are getting the highest power gain. Highest power gain, guys. Okay. Now, it may be 180 or minus 180, doesn't matter. Common collector. Common collector means the voltage gain is lowest, nearly equal to 1. Lowest, nearly equal to 1. But what about the current gain? Highest. Highest. What about the input resistance? Very high. Among the three configuration, highest input resistance. What about the output resistance? Very low. Power gain moderate. Power gain is moderate and 0 degree phase shift. So, is there any use? Yes, buffer. We are designing the buffer. Buffer means impedance matching device between high resistance and low resistance. Because its input resistance is very, very high, it is used as a buffer. Now, common base, just opposite. What about the voltage gain? Very high. What about the current gain? Alpha, nearly equal to 1, very low. Low. Among three configuration, lowest. Input resistance, low. Output resistance, very high, in the range of what? Mega ohm. It is in the range of mega ohm. Power gain moderate. Phase shift 0 degree. Again it is used as what? Buffer. Buffer means low input resistance, high output resistance, matching. That is called impedance matching device. Impedance matching device. Okay. So these are the applications of what? Common emitter, common collector, common base. Very, very important characteristics, guys. So you can make notes of this, or otherwise you can download the PDF. देखो सबसे important जो है ना, your notes, right? Your notes are very, very important, guys. Always remember. तो अगर अपने जूनियर्स को या किसी को आपको प्रिपरेशन करनी है, then start your preparation for 2026 and 2027. बिल्कुल ऐसा बोर्ड रहना चाहिए प्लेन जैसे ये था. And now write all the things. Okay. तो 4 or 5 times when we are writing now, automatically you will get the command over particular topics. बार बार लिखने से वैसे ही प्रैक्टिस हो जाती है और वैसे ही आपको चीजें याद हो जाती है. लेकिन उसके लिए क्या है, थोड़ा टाइम चाहिए. आप सोचते हो 15 दिन में, जिसका हो गया है ओके. These all the sessions for those guys already prepared the subjects. उनके लिए जो ऑलरेडी सब्जेक्ट्स में कमांड है, क्विक रिवीजन करना है. कोई सोचेगा कि 4 घंटे में टॉपिक तैयार हो जाए, प्रैक्टिकली नॉट पॉसिबल. हाँ, लेकिन 1 साल अगर वो है और अगर आपके 4 या 5 सब्जेक्ट भी बहुत ही ज्यादा एक्स्ट्रा ऑर्डिनरी हो गए, तो यार आप आराम से लाइफ में ना बिल्कुल सेट हो जाओगे. फॉर एग्जाम्पल एनालॉग एंड डिजिटल. इफ यू हैव द कमांड ओवर द एनालॉग एंड व्हाट डिजिटल, तो वीएलएसआई में क्या चाहिए? एनालॉग एंड डिजिटल चाहिए. ठीक है. फिर उसके बाद देखो ऑलरेडी आपके 3-4 सब्जेक्ट अगर स्ट्रांग हो गए तो आप गेट में अच्छी रैंक ले आओगे. आपको फिर बाकी सब सब्जेक्ट सपोर्ट करता है. नेटवर्क, डिजिटल, कंट्रोल, सिग्नल एंड सिस्टम, ये सब बेसिक सब्जेक्ट है. कोर क्या है? ईएमएफटी, कम्युनिकेशन, एनालॉग, ईडीसी. ठीक है, ये 4 कोर है. सिमिलरली आप इलेक्ट्रिकल में जाओगे तो मशीन, पावर सिस्टम, पावर इलेक्ट्रॉनिक्स, मेजरमेंट. कई स्टूडेंट्स अब सोचेंगे मैं सर डेटा साइंस एंड आर्टिफिशियल इंटेलिजेंस से गेट दे दूं, तो यस वो भी पॉसिबल है. अब आपको डिसाइड करना है कि आपको करियर में क्या करना है. कंफ्यूजन नहीं होना चाहिए भाई, हर लाइन ऊपर जाएगी, हर इंजीनियर्स की डिमांड है, ऐसे ही ब्रांच नहीं चल रही है. नाउ तो व्हाट इज द यूज हियर? बफर. इसलिए मोस्ट पॉपुलरली यूज्ड कॉन्फ़िगरेशन इज कॉमन एमिटर बिकॉज द पावर गेन इज हाईएस्ट, Most popularly used configuration used in what? Multi-staging, multi-stage amplifier. Multi-stage amplifier we are using the common emitter configuration. अब ये टेबल हो गई, इस पे क्वेश्चन आ जाएंगे. अब हम बनाएंगे क्वेश्चंस. तो क्वेश्चंस बनाने के लिए गाइज वी आर यूजिंग द डिफरेंट मॉडल्स. We are using the different models. So just in a GATE exam there are two models and they are applicable for what? Common emitter, common collector, common base. First model is what? Pi model. तो मैं आपको बता दूं pi model का आपको यूज कैसे करना है. This is R pi. I'm giving you the approximated model and this is called GMV pi. This terminal is called collector, this is called base, and that is what emitter. What is this V pi? That is nothing but voltage across this. V pi. Right. So this is a small signal model, guys. Small signal model. This is called pi model. We will solve question based on this. Here we have to find the transconductance GM. IC upon VT. From DC analysis, first of all find the IC, then volt equivalent of temperature, T by 11,600 volt. And what is the value of the VT? At 25 degrees centigrade, VT is given by 25 millivolt. Otherwise, in particular question, they will give you the value of VT. Okay. ये हो गया. GM you have to find. R pi. Sometimes they will provide you in the question, otherwise R pi. Beta by GM. Beta by GM. HFE by GM. You have to find from this. याद रखना आपको पहले GM निकालना है. You have to find the GM then what? V pi. GM then R pi. Sorry. Yes. Raj, we will discuss those questions, RS or so on. So this is the GMV pi and that is the R pi and this is the emitter. So that is the model. Base, collector and what? Emitter. This model is applicable for common emitter, common collector, common base for all the configuration. Similarly, we have the different model. That is the second one model is RE model. What is the RE model? Like this. Alpha IE. This is the resistor RE and this is the base terminal B, collector terminal. Alpha is also the current gain, that is the IC is equal to alpha I, or you can say IC is equal to what? Beta IB. What is the relation between alpha and beta? Alpha is equal to beta upon 1 plus beta. Alpha is equal to beta upon 1 plus beta. So that is the RE. So in this particular diagram, you have to find the RE. What is the RE? VT upon IE. You have to find the IE from the DC analysis, then volt equivalent of temperature, find the RE, then you can use this model. If the alpha is not given, then beta is given. So from the beta, you can find the alpha. Or otherwise, you can also replace it by what? Beta IB. Same thing. No, don't worry. What about this emitter current? This is the IE. What is this base current? IB. So always remember what is the IE? 1 plus beta times of what? IB. 1 plus beta times of IB. IB plus IC is equal to what? IE. So this is the RE model. Collector. This is the emitter terminal. This is the base terminal. So this is called RE model. So these are the small signal model. All the questions we can solve by using these two models. Okay. RS को भी कंसीडर करेंगे, कैसे RS को कंसीडर करना है, कैसे लगाना है एंड सो ऑन. ये आते हैं हम लोग इस पर. अब तीनों मॉडल है. अब H पैरामीटर मॉडल पे ज्यादा क्वेश्चंस नहीं आते. आपको करना क्या है, देखो, जब भी आप कोई क्वेश्चन सॉल्व कर रहे हो on AC analysis, right? So there are two analysis. One is called DC analysis. So already we have solved number of questions on DC analysis. DC analysis means find the value of IC, find the value of what VCEQ, and so on. During DC analysis, all capacitor act as what? Open circuit. So suppose you are getting some capacitor, make it what? Open circuit during DC analysis. Apply the potential divider, find the value of IC, VCEQ, terminal voltages, VC, V, right, and so on. This is called DC analysis. What is the AC analysis? During AC analysis, all the DC sources should be zero. For example, if it is voltage source, act as short circuit, current source, it acts as open circuit. All the capacitor act as what? Short circuit. जितने भी आपको बाहर में कैपेसिटर दिखाई दे रहे, whether it is a bypass capacitor or coupling capacitor, they all act as what? Short circuit. Short circuit, right? And then the BJT should be replaced by its small signal model. Small signal model. BJT should be replaced by what? Small signal model. Linear model. We have to maintain the linearity. So three precautions or three guidelines है. पहला, all the capacitor will act as short circuit. All the DC sources tends towards zero, and then BJT should be replaced by its internal model. Remove the DC sources, short circuit the capacitor, replace the transistor. When I am talking about remove the DC sources means make it what? Zero. Make it zero. अभी मैं आपको बताता हूँ, देखो मॉडल में से ये देखिए ये है. This is the first of all fixed bias circuit. Right? Without numerical value, you will get the command over that. Okay, everyone, try to draw the model. Try to draw the model in your copy. In your copy, guys. So we are taking the 10 minutes break. After 10 minutes, everyone share the link of this session, like the session. Okay. So that now you are going to get the command, or within the next 2 hours we will get the command over what? Small signal model, and we will solve some questions from previous year question paper. जो भी अभी तक आपने देखा है ना, उसको अप्लाई कैसे करना, तो 2 से 3 घंटे में अब आपकी कमांड हो जाएगी कि कैसे हम उसको अप्लाई कर सकते हैं. राइट? तो सब एक बार जरा लाइक कर लीजिएगा, और आप कोई सजेशन देना चाहते हो, कमेंट्स देना चाहते हो तो आप दे सकते हैं. आप ऐप डाउनलोड कर लीजिए, इस बीच में कोर्सेज के बारे में थोड़ा डिटेल ले लीजिए, और ये क्वेश्चन बनाओ. ये बना हुआ है, कैपेसिटर विल एक्ट एज शॉर्ट सर्किट. आरएस आई एम गोइंग टू कंसीडर आरएस हियर. दिस इज द आरबी हियर, वीसीसी हियर, आरएल इज हियर. इट इज अ फिक्स्ड बायस सर्किट. मॉडल में कनेक्ट कैसे करना है, एक बार आप कनेक्ट कीजिए, देन अप्लाई द कॉन्सेप्ट ऑफ नेटवर्क, तो आराम से बन जाएगा. ओके, तो जस्ट 10 मिनट ब्रेक. Try to solve this. Tomorrow we have the session on MOSFET, Raj. Day after tomorrow, MOSFET. नाउ चलिए स्टार्ट करते हैं. हाउ टू ड्रॉ द स्मॉल सिग्नल मॉडल गाइस. सेशन नाउ. देन analysis of common emitter amplifier with fixed bias circuit. Fixed bias circuit, so how we can connect in model? First, these two capacitors, these are called coupling capacitor. Normally the value of these coupling capacitor are very large, very large, right? Then what is the impedance? 1 by omega c. So when the value of the c is very large, the impedance is very low, very small, and that's why act as what? Short circuit. Capacitor act as short circuit during AC analysis. तो during AC analysis आपका कैपेसिटर क्या हो जाएगा? शॉर्ट हो जाएगा, राइट? तो देखते हैं ये फिक्स्ड बायस सर्किट में अब कनेक्शन कैसे करना है वो हम लोग चेक करेंगे. हाँ, कनेक्शन को आप चेक करते हैं जरा. राइट नाउ अब आप क्वेश्चन पूछ रहे हो विच वन इज द बेस्ट सेल्फ बायस सर्किट और फिक्स्ड बायस सर्किट. तो गाइज इन सेल्फ बायस सर्किट वी हैव negative feedback, that's why that is stable, or in fixed bias circuit there is no feedback, that's why it is point very stable. But if variation in the temperature is negligible or we want more gain, then we have to use what? Fixed bias circuit, क्योंकि वहां कोई negative feedback नहीं. अब देखते हैं, देखो ये लार्ज है, लार्ज कैपेसिटर will act as short circuit. This DC supply will act as what? Zero, short circuit. VCC short circuit. This is the signal, this is the small signal, and its internal resistance is RS. Connection here, watch. Most important thing is what? Connection. For example, if you are going to use what? RE model, right? RE model. First of all, draw the RE model. This is RE, right? You have to find the RE from the DC analysis. What is the RE? VT by IE. In numerical, we will solve VT by IE. So this is RE model. Now this is base. This is collector. And alpha I. Alpha is equal to beta upon 1 plus beta. And that current is what? IE. And this is the model. Now, this is collector. This capacitor will act as short circuit. This will act as zero. First, emitter. Emitter is connected to ground. Watch this. Emitter is connected to ground. So you can make a common ground here. This is the transistor, guys. Transistor is replaced by small signal model. So transistor is replaced by small signal model. This is common ground here. Common ground. Then this is zero. This is base. So base to ground we have one resistor that is called RB. From base to ground. From base to ground we have one resistor RB. Right here the base current IB. Then from base to ground this capacitor will act as short circuit. We have the RS and VS. RS and what? VS. This is the sinusoidal signal RS and VS. Okay. Now from collector to ground we have the RC. From collector to ground we have RL. So RC and RL are in parallel. Collector to ground RC and RL, and we are taking output from what? Collector. This is the output. And that is the input. So this is the connection. Is it clear? Any doubt? कि आपको क्या करना है? Emitter is connected to ground, collector to ground RC, collector to ground RL, then base to ground RB, base to ground RS and VS. This is the alpha I, RC and what? RL, and that is the V naught. Okay. Now how to find the gain? Gain means V naught versus Vi. Up to this point, this is called V naught versus Vi. Up to this point, it is called V naught versus Vi. But when we have to find a V naught versus Vs, then that is a different story. So normally what will happen? RS is not given. RS is normally 0. If the RS is 0, first case, if the RS is 0, then Vi and Vs are equal because that is connected in parallel. So Vi and Vs are equal. So first of all I am considering the first case, then second case. Let in this diagram RS is 0. RS is not given. Then Vs is equal to Vi. Parallel. Vs is equal to what? Vi. In that case, what is the midband voltage gain? V naught upon Vi or V naught upon Vs? Both are same. Now, what is the V naught? What is the current here? Minus alpha I. These two resistors are in parallel. So, you can directly write minus alpha I into what? RC parallel with RL. These two resistors are connected in parallel. Upon I into Re, because this is Vi. Vi is nothing but voltage across this I into Re. I cancel, and what is the answer? Minus alpha RC parallel with RL upon what? Re. And that is the answer for this particular question. That is called what? Voltage gain. Itna simple hai. Easily you can solve. Right? So this is the answer, minus alpha RC parallel with RL upon Re. So this is called what? Voltage gain, midband voltage gain when the RS is 0. When the RS is 0. Right? But if the RS is not 0, then how we can find? If the RS is not 0, then how we can find, guys? Okay. Now, that is very, very important question. If the RS is not 0, non-zero values. If the RS is 0, that is the answer. So, in the 99% case, that will be the answer in GATE exam. But if the RS is not 0, then same model, everything will remain same. Alpha, if the beta is very, very large, you can say alpha is nearly equal to 1. If the beta is very, very greater than 1, so you can take alpha is equal to what? 1. RC parallel with RL. We will solve numerical. RC parallel with RL upon small Re. Or Re is what? Vt upon I, volt equivalent of temperature upon emitter current. You can find the Re. So normally Re, it is in the range of what? Ohm. RC and RL, it is in the range of what? Kilo ohm. So remember, RC and RL in kilo ohm, convert it into ohm, and Re is, it is in ohm. If the beta is not given, beta very large, alpha will become 1. It is the solution without RS. But if the RS is given, for example, this RS is given 100 ohm, something else, then how we can find? Then different story, guys. Different story means, first of all, let the RS is not 0. Non-zero values. Then first find the V naught upon Vi like this. Then V naught upon Vi is equal to same logic, V naught upon Vi minus alpha I RC parallel with RL. This is the V naught. What is the Vi? I into Re. I cancel. That is the V naught upon Vi. So first of all, find the V naught upon Vi. Then once you have the V naught upon Vi, what is the V naught upon Vi? V naught upon Vi into what? Vi upon Vs. Vi cancel, V naught upon Vs you will get. So V naught upon Vi you have already minus alpha RC parallel with RL upon what? Re. Now you have to find the Vi upon Vs. अब Vi upon Vs कैसे निकालना? तो Vi upon Vs निकालने के लिए in the same model, guys, in the same model, first you have to find the Ri here at this point. Ri. What is the Ri, guys? Ri means input resistance. input resistance, what is the voltage at this point? Vi. What is the current here? Ib, not IE. What is the current enter through this node? That is the IB. IB. So Vi upon what? IB. That is the current. Vi upon IB you have to find. Now, what is the Vi upon IB? So watch this, how we can find the Vi upon IB. What is the Vi? IE into RE. Right? Watch this. What is the Vi? IE into RE. This is the IE into RE parallel. What is the IE? IE is nothing but IB plus IC. IB plus IC, or IE is equal to 1 plus beta times of IB into RE. Right? 1 plus beta times of IB into RE, because IE is equal to 1 plus beta times of IB, IC plus IB. So now you can find the Vi upon IB, that is nothing but 1 plus beta times of RE. 1 plus beta times of RE. That is called input resistance up to this point. Always remember, this is a very, very important question. What is the input resistance up to this point? 1 plus beta times of RE. Now, once you have the input resistance up to this point, 1 plus beta times of RE. Now, what is the input resistance up to this point? Ri dash. What is the input resistance up to this point? If the RB is not given, Ri and Ri dash are same. But if the RB is given, Ri dash is nothing but RB parallel with Ri. RB parallel with Ri. Ri dash is nothing but Ri parallel with RB. और Ri आपको पता है, what is the value? 1 plus beta times of small re parallel with RB. Okay. Now you have the resistor at this point. What is the voltage at this point? Also Vi. We have to find the Vi upon what? Vs. Now you can take this portion only. You can take this portion only. So what is this portion? 1 minute. Take this portion only. Remove all this portion. Okay, remove all this. Okay. Now, so what about the remaining? That complete portion is replaced by what? Ri dash. This is up to this point. So this is the RB. RB is removed. This Ri dash. It is replaced by what? Ri dash. And what is the voltage across the Ri dash? Vi. So according to voltage divide rule, now you can find the Vi upon Vs. Ri dash upon what? Ri dash plus Rs. Now what is the overall voltage gain? Overall voltage gain will become V0 upon Vs. That is nothing but V0 upon Vi into Vi upon Vs. So already we have, this is the value minus alpha Rc parallel with RL into what? Upon Re. And what is the Vi upon Vs? Ri dash upon Ri dash plus Rs. Where Ri dash is Rb parallel with 1 plus beta times of Re. So, Rb parallel with 1 plus beta times of Re. So, if the Rb is not given, then it will become 1 plus beta times of Re only. So, that is the question. So, I think now Raj, it is clear to you how to find the V0 upon Vs if the Rs is given. So, don't worry about the Rs. Use the concept of what? Network. We are using the voltage division rule here. Voltage division rule. And remember, when I am talking about the input resistance at this point, this is the Vi upon Ib, not the Vi upon IE. No doubt, Vi is equal to what? IE into Re, but we have to find the ratio Vi upon Ib, and very easy. IE is equal to what? 1 plus beta times of Ib. Directly you can find the ratio 1 plus beta times of Re. Okay. ये है 1 plus beta times of Re. Now, That is a small signal model, guys, with RS. So in this way we can solve the fixed bias circuit. So 99% question based on this diagram. Very easy. So use this concept, get the voltage gain, get the idea about that question. Okay. At the end I will give you the shortcut. Then this is about the fixed bias circuit. Now the analysis of the common amplifier with common emitter amplifier with what? Self bias circuit. For example, if this type of circuit is given, watch this type of circuit. C1, C, this is the bypassed RE. This is called bypassed RE. If the RE is connected, one capacitor is connected parallel to RE, this is called bypassed RE. Bypassed emitter resistance. So at AC analysis, what will happen? This capacitor will act as short circuit. This will act as short circuit. This will act as short circuit. So again, it is just like a fixed bias circuit. First of all, draw the model. RE, this is base, this is emitter, and this is collector. First, now because capacitor is connected, it will act as short circuit. This is connected to what? Ground. Again emitter is connected to ground. Make common ground here. Make common ground here. Then VCC 0. This capacitor act as short circuit. This act as short circuit. This act as short circuit. Then from collector to ground, RC and RL, just like a previous question. RC, RL. We are getting output from this collector. Same logic. Now, from base to ground, R1 and R2 are connected. From base to ground R1, from base to ground R2. So these two resistors are connected in parallel. R1, then R2. R1 and R2 are parallel. Then RS and VS is connected. RS and VS is connected. Now my dear friend, tell me, what is the difference between the previous diagram and that diagram? In place of RB, we are having what? R1 parallel with R2 only. Nothing difference. In place of RB, we are having the R1 parallel with R2. And this is the VI. Right? This is VI, this is VI, this is VI. Same, everything will remain same. If the RS is 0, again we are getting the same answer. If the RS is 0, you will get the same answer. Minus alpha I RL dash. What is the RL dash? RC parallel with RL upon what? Small re. Same answer. A small I into RE. So I cancel. Minus alpha RC parallel with RL upon RE. Same answer. If the RS is present, then you have to use the same logic. Right, just like a fixed biased circuit, guys. Okay. Now all are, I think you can solve this type of questions. This one. If the RS is given, then try to solve like this. This one. हो गया दो क्वेश्चन. So if the bypass resistor RE is connected, it is just like what during AC analysis, it is just like a fixed bias circuit. Okay, there is no difference. No difference. At the end, I will give you the shortcut. Now, if it is not bypassed, if RE is not bypassed, then what type of model? If RE, this is RE is not bypassed. So this is the diagram. Analysis of common emitter amplifier with self bias without C. RE is connected, it is called self bias circuit, but C is not connected here. If the C is not connected here, then what is the AC analysis model? Watch the model carefully. Alpha I, small re, emitter, this is base. This is the model. Transistor is replaced by its internal model. Now, this capacitor will act as short circuit, this will act as short circuit, this is 0. Now guys, emitter is not connected to ground. Between emitter and ground we have is capital RE. So first of all connect, this is the capital RE. Outside the transistor, capital RE. Now this will become ground. Common ground. Okay, this is the ground. This is the RE. Now from collector to ground, RC and RL are connected just like a previous case. Electrical and electronics students, this is a very important model and very simple. RC parallel with RL. Small signal model. V0. We are getting the output from the collector terminal. Now, this is the base to ground R1, base to ground R2, it is connected. This is the ground now. This is called R1 parallel with R2, that is the RB. R1 parallel with R2. Now RS and VS is connected. RS and VS is connected here. This is the model guys, simple model. Now what is the current here? IE. What is the current here? IB. What is the current? This is IC. IB, IC, I. Now what will be the output voltage? Output voltage is nothing but what is this is alpha I. So what is the current here? Minus alpha I. So if the RS is not there, for example, in 99% case in GATE exam, RS will be 0. If the RS is 0, first case, RS is equal to 0. If the RS is 0, there is no RS, then this is 0, short circuit. Then this Vs or voltage at this point are same, Vi is equal to Vs. Then again it will become very simple question. V0 upon Vs is nothing but, which is called midband voltage gain, V0 upon Vi is equal to, what is the output voltage? Minus I into RC parallel with RL upon, now what is this current? IE is multiplied with what? Small re plus capital RE. So IE cancel. What is the exact answer? Minus alpha RC parallel with RL upon small re plus capital RE. That is the answer. So if the RE is not bypassed, you have to add the capital RE here. If it is bypassed, then remove it. Simple answer. Minus alpha RC parallel with RL and RE plus RE. So that is the answer. Now I am giving you the shortcut here. So watch this diagram. There are two things. First, if nothing is connected here, like this is RL, this is RC, this is VCC. RS is not given, right? If the RS is not 0, so that Vi upon V0, this capacitor is connected here, this is the V0. Very easy. Directly you can write this formula. V0 upon Vs is equal to, V0 upon Vs is equal to minus alpha RC parallel with RL upon what? Small re. or it is nearly equal to RC parallel with RL upon RE because alpha is nearly equal to 1 upon small RE. That is the gain with 180 degree phase shift. It is a standard diagram. If the RS is not given, RS is equal to 0. Directly you can write this formula, minus RC parallel with RL upon RE, small RE. Okay, this is the small RE. Now, if suppose in a particular numerical RL is not given, this type of diagram even. Here the connection is given but RS is not given. RL is not given. So straightforward you can write the answer V0 by Vs is equal to minus RC upon small re, or minus alpha RC upon small re. That is the RL is not given, means RC parallel with infinity is what? RC. ये हो गया answer. Then same question, RE is given but it is bypassed. Same question but RE is given but it is bypassed. Bypass means during AC analysis this capacitor will act as short circuit. So same answer we will get. Same answer you will get. Again same answer, right? Then if the RE is given but it is unbypassed, unbypassed means capacitor is not connected. RE is given, capacitor is not connected. Then guys, remember the formula is here. This small RE is replaced by small RE plus capital RE. Small RE plus capital. This is the exact answer, but alpha is nearly equal to 1 and this is in kilo ohm. Normally it is in kilo ohm and it is in ohm. So remove it and it is nearly equal to RC parallel with RL upon capital RE. That is the approximated answer, overestimated, because we are removing the RE, we are removing the alpha. So this is the higher value, so overestimated. That is the standard answer. If the RS is not given, in all the questions I am not considering the RS. Already I have given how to consider the RS. Or this answer will become RC upon small re plus capital RE. If the RL is not given, it is nearly equal to what? Minus RC upon RE. Remove this because it is in normally in ohm, it is in kilo ohm. This is very, very high as compared to that. Okay, all the questions we can solve on the basis of these four formula, guys. That is a small signal model. Small signal model, guys. These days we are using the common emitter with RE. Okay. So are you ready to solve some questions? Now, watch this question. For the DC analysis of the common emitter amplifier, neglect the base current and assume that the emitter and collector currents are equal. So beta is not given, so you can neglect the base current. Then given that VT means volt equivalent of temperature 25 millivolt, VB is 0.7 volt, R0 output resistance is infinite. The mid-band voltage gain, when I am talking about the mid-band voltage gain, means it is what? At not at higher frequency, not at lower frequency, it is at what? Mid-band voltage gain. So in my class already I have discussed what is the meaning of the mid-band voltage gain. It is a quick revision class, guys. Okay. So if you want what is the mid-band voltage gain, please write in comments. Then what is the gain of these amplifier? So this 2 kilo ohm is bypassed. It will act as short circuit. This is bypassed. This will act as short circuit. 2 kilo ohm and 8 kilo ohm are parallel. This will act as what? 0. RS is not given. Bolo na 99% RS is not given. Very, very easy question. 73 and 47 are parallel. But first of all, you have to find the small RE. Just to find the small RE, you have to do the DC analysis. During DC analysis, all the capacitor will act as what? Open circuit. During DC analysis, this capacitor will act as open circuit. Remove this. This capacitor will act as open circuit. This capacitor will act as open circuit. That is the diagram. So during DC analysis, this is the diagram. Now, apply the Thevenin's. Base current is negligible, so only find the VTH. Only find the VTH. 47 upon 73 plus 47 into what? 12 volt. So 73 plus 47, that is 120. So that is what? 4.7 volt. So VTH is what? 4.7 volt. Then no need to find the RTH. 4.7. What is the voltage at this point? 0.7. And what is the value? 2 kilo. Now you can find the I. I and IC are same. I. What is the value of the I? You can find I is equal to 4.7 minus 0.7. 4.7 minus 0.7 upon 2. So it will become 2 milliampere. 2 milliampere. Once you have the value of I, you can find the RE. VT upon I. 25 divided by 2, 12.5 ohm. Because it is in millivolt, it is in milliampere. So milli cancel, it is in ohm. 12.5 ohm. Remember, otherwise you will write the kilo ohm, that answer will be wrong. 12.5 ohm. Okay. Now you have the RE. So you can replace it by what? It's a small signal model. Or directly you can use this formula. What formula? This is bypassed. Then directly you can use this formula. V0 upon Vs is nothing but V0 upon Vi. Why? Because Rs is 0. Rs is not given. This is bypassed. If this is bypassed, what is the formula? Minus alpha Rc parallel with RL upon Re. What is the alpha? Beta is very, very large. Alpha is 1. Rc 2 kilo ohm. Parallel with 8 kilo ohm. Upon Re 12.5 ohm. That is in kilo ohm. What is the parallel combination of 2 and 8? 16 divided by 2. 2 and 8 means 16 divided by 2. 16 divided by 10. Kilo ohm multiplied with the 1000. That is converted into ohm upon 12.5. So it will become 1600 divided by 12.5 with negative sign. राइट, दिस इज द आंसर. देखो कोई मॉडल बनाया मैंने, मॉडल बनाने की जरूरत ही नहीं है, डायरेक्ट यूज द आंसर. -128. -128. डी इज द आंसर. -128. तो ये क्वेश्चन आपको बताता है क्या निकालना है इसमें. स्मॉल आर ई. Right, small RE from the DC analysis. First of all, do the DC analysis. Thevenin's. All the capacitor will act as open circuit. Then find the RE. Once you have the value of the RE, no need to draw the model again and again. Standard answer. Use this because RS is not given. Directly you can find the answer. And check my calculation also. Okay, that is the answer. Okay, this type of questions. So this is a very, very important diagram. Number of times question from this diagram. Question from this particular diagram. Okay. Then second type of diagram is like this. Collector based bias circuit, guys. In electrical engineering, that was the previous year question. Second type of diagram. Here 10 kilo ohm, it is RS is connected here. You can say RS, this is the RF. this is the RC, beta is given 100, voltage gain AV of the circuit given below. Or this is the symbol of what? Approximated gain. Approximated gain. If the voltage gain is required, voltage gain for this particular circuit is required, directly I am giving you the shortcut. Otherwise you have to apply the Miller's theorem. Then in electrical branch, if this question is given, then directly you can solve, guys. In this particular question, no doubt you can connect the models, or you can connect, or you can find the answer by using the use of what network, right? But I will give you the model also. But here, the answer for this question is straightforward. The answer for this question is nearly equal to minus RF by RS. Minus RF by RS. This is the feedback resistor RF and this is the RS. 100 by 10, that answer is what? Minus 10. Approximated answer is minus. And it is overestimated. Means actual answer is less than that. Slightly less than that. But here 20, 100, 200, no, not possible. It is actually less than 10. But what is the approximated gain? 10 D. Straightforward. This is the question from electrical branch. RF by RS. No need to apply the model and so on. But suppose you want to apply the model. Nothing is given. What is the beta? Very, very large. Base current negligible. Then how we can apply the model here? This will act as 0. Right? Then first of all, IC and IE are equal. DC analysis. You have to do the DC analysis and then what? AC analysis. But according to the given information, you have to apply the approximated formula, but I am giving you the method. During DC analysis, this capacitor will act as what? Open circuit. You can make it what? Open. What will be the current here? 0. Beta 100 it is given. Then this is the current IB, this is the current IC, and what is the current here? IE, IC plus IB. And what is the current here? Again IC plus IB. IC plus IB is nothing but 1 plus beta times of IB, 101 times of IB. You have to do the DC analysis first. All the capacitor act as what? Open circuit. Then you can write here 13.7 is equal to 12 into 101 times of IB plus 100 IB plus 0.7 volt. This is the 0.7 volt. So you can find the IB 13.7 minus 0.7 upon 100 plus this is multiplied right, that will become, and then you can find the value of IB. From IB you can find the value of IE. What is the value of IE? 1 plus beta times of IB. Then you can find the value of RE. What is the RE? VT upon IE. 25 millivolt divided by IE. This is in milli, this is in milli, it is in ohm. Can you find this? Yes or no? I am not giving you the numerical value, but it is very, very easy. Find the value of IB. 1 plus beta means what? 101 times of IB. You can find the value of what? IE. Then finally you can find the value of small RE. Once you have the value of the RE, then you can use the model, guys. Then you can use the model here. What is the model? Small signal model. Small signal model, this will act as 0. 0. This capacitor will act as short circuit. This capacitor will act as short circuit. So when small signal model means this is the model. Alpha I, small RE, emitter is connected to ground. This is the emitter is connected to ground. Then from collector to ground 12 kilo ohm is connected. This is the base. This is collector. Collector to ground. 12 kilo ohm is connected here. Right? Now, watch this. This is the base. Base to ground, 10 kilo ohm and VI is connected. VI is connected. Now there is a one problem. There is a one resistor connected between what? Base and collector. So base and collector we have one resistor. This one. 100 kilo ohm. 100 kilo ohm, guys. And that is the problem. That is the problem, guys. You can solve this problem by using the Miller's theorem, or directly you can apply the network here, guys. It's up to you. If you want to apply, this is the base current IB. Okay. This is the alpha I, that is the output current I0. Right. And we are getting the output from the collector V0. If you have no idea about the Miller's theorem, then simply apply the network and you have to find the V0 upon Vi. Let this current is what? This is the I. I is nothing but 1 plus beta times of IB, that is 101 times of IB. Okay. It is also called beta IB. Alpha I is also called beta IB. It is also called the beta IB. So what is this? 100 times of IB. So you can write in terms of what? IB. Remember, this is the IC current. IC you can write alpha I or you can write the beta IB. If you are writing the beta IB, it will become 100 times of IB. IB 100 times of IB, 100 times of IB. Now, you have to write the one KVL, guys. I'm giving you the shortcut. This is the current I. What is the current here? I minus IB. I minus IB, because this is the current IB. Then what is the current here? I0. I0 will become I minus IB minus beta IB. So this is become I minus IB minus beta IB, means 1 minus beta times of IB. 1 plus beta times of IB. This is the beta IB, this is the IB. Then that is the output current. Right. So you can write the output voltage is equal to this is the output voltage multiplied with what? Load. 12 kilo ohm. So here ये बड़ी problem है. How we can find then? Finally, what is the answer here? Then you can also write the VI. I into 10 kilo ohm plus I into 10 kilo ohm plus 101 IB into RE. This is the what is the loop? So this is called 1 plus beta times of IB into what? RE. What is the RE? Already we have the answer RE. Right. Now V0 upon Vi you have to find. But how we can cancel out? You have to find the IB, guys, in terms of what? I. So that you will get the common term. How we can get the relation between IB and I? So you have to write one KVL here. Where we can write the KVL? Where we can write the KVL so that we will get the relation between IB and what? I. So yes, you can write the KVL. You can start from this point. Write down the KVL. If suppose you are not going to use the Miller's theorem, otherwise with Miller's theorem it will become very easy. This is the KVL. Write down the KVL here. It will become 100 times of I minus IB okay, plus 12 times of I minus 101 times of IB. This is the 101 times of IB. फिर देखिए, this will become minus 101 times of IB into small re, that is equal to 0. That is equal to what? 0. Now from this you will get the relation between what? IB and what? I. Once you have the relation between IB and I, you can replace this. Or you can also find the what is the value of the 1 plus beta times of IB also. 1 plus beta times of IB also you can find. Now get the relation between IE and IB, put here, divide it, and you will get the exact answer. But already I have said now, no need to. I have given you the idea how to find the exact answer without Miller's theorem. Without Miller's theorem, how we can find the exact answer, guys. Otherwise, what is the shortcut here? Simple. Minus RF by RS. If you are interested with Miller's theorem, then please write here. I will arrange one session for that by using the Miller's theorem. It is a quick revision session actually. Okay guys, so remember in this type of questions, minus RF by RS. It is an approximated answer, overestimated answer. Answer will be less than that. Minus 10. Or everyone, that is the assignment. Find the relation between IE and IB from this, because we have the two things only, IB and IE. Find the IB in terms of I, put here. Divide it, I cancel, and you will get the exact value of V0 upon Vi. And definitely it will be less than minus 10. It will be less than minus 10. Okay, so this type of questions you will get, guys, from the transistor. So hope you have enjoyed the session, guys. Now, sometimes we are getting question on what question like voltage regulator. Last question, voltage regulator. What is a voltage regulator here? The 3-terminal linear voltage regulator is connected to a 10 ohm load resistor as shown in the figure. 3-terminal linear voltage regulator. That is the application of what? BJT. This is called series voltage regulator, right? This is a series voltage regulator. I think that load resistor is missing. I think load resistor is missing. V in is 10 volt, right? Okay, then what is the, because if the load resistor is not given, this voltage is VB 0.7 volt. There will be the one load resistor, right? So in diagram that is missing. V in is what? 10 volt. What is the power dissipated in the transistor? You have to find power dissipated in the transistor. Because of that short circuit, that there will be the large current there. Leave it. So next class we will cover questions on what? Different topics. So already I have given you the question, number of questions we have solved. Now try to solve the previous year question. It will become very easy for you to solve the questions, guys. And already I have covered the topics for what? Electrical branch. Now tomorrow we have session on what? Operational amplifier. And day after tomorrow we will solve questions on what? MOSFET, metal oxide semiconductor field effect transistor. So stay tuned with me, subscribe the channel, and if you want to join some small courses on operational amplifier, MOSFET, BJT, you can join topic wise. To go through the app, that is the Prep Funda, download from description, the link is given in description. Google Play Store में आपको link मिल जाएगा, download कर लीजिए और go through the courses available for you. Okay, then thank you very much for attending the session. Have a nice day. Thank you.